360. Zurück ins Leben. Komm mit mir auf eine Reise. Eine Reise zu mehr Energie und fantastischer Gesundheit. Ich möchte dir das Wissen und den Mut vermitteln, den ich gebraucht hätte, als ich ganz unten war. Dabei will ich dir helfen, wieder richtig in deine Energie zu kommen. Zurück ins Leben.
Hello and welcome to the Bio360 podcast. My name is Unkas Gemmiker and today we're going to talk about oxalates. What are they and how dangerous are they really? My today's guest is a nutritional therapist and functional medicine practitioner. Please welcome with me from the UK, Elliot Overton. Hi, Elliot.
Hi, Unkas. Thanks for having me on.
And I'm really happy to have you on, and I'm really happy to talk about this super interesting topic and to bring it to Germany, kind of. I mean, this is a worldwide podcast, and the moment I use the English language, of course, everybody can listen to it. But yeah, my podcast is based in Germany, and in Germany, nobody seems to know anything about oxalates. So I make this kind of a mission. So I will kind of make a translation also of our, not a full translation, but I will make a resume of it so I can inform people more about it. Before we jump into the topic, maybe you can tell us something about yourself, how you came to talk to that subject actually.
Okay, right. So yeah, the topic of oxalates is a bit of a rabbit hole when you start to go down it. As I said, I am trained as a nutritionist. I work with people in clinical practice, try to improve their health. I try to utilize what we call functional medicine. So we try to get to the kind of root cause or investigate what is driving chronic health issues and then addressing the causes. And time again, what I have found is that the traditional kind of functional medicine interventions using various nutrients and various diets are frankly not as effective as I would like them to be or as they are purported to be. For many individuals, well, there is this central nutritional dogma, and this is what practically every kind of nutritionist would learn when they study, whether it go through the conventional university route or whether it be through some kind of so-called alternative route. This dogma that the more plants that you eat, the healthier you will become, right? And this is just so common, especially with many of the world-leading authorities now recommending things like plant-based diets. There is this notion, and it's really been adopted by the general population, that if we eat more plants, then we become healthier. And unfortunately, in my position, I'm in a situation where people put trust in me and they expect me to be able to provide them with advice that is going to improve their health. Now, what you often see is that whilst there are some people who benefit from plant-based diets, there are other people who, when they eat more plants, they actually get worse. They might feel better temporarily, but actually when they start increasing the load of plants, especially the so-called superfoods, which I'm sure we'll talk about later, the more superfoods that someone eats, actually the sicker they get. And so seeing this kind of thing recur over and over, it kind of really led me to want to dig into the topic of why this actually happens. And, by chance, I stumbled across some information. I was actually doing some research on sulfur and sulfur metabolism, investigating some other kind of rabbit hole. And then actually I stumbled across this topic of oxalates. Now, I'd been kind of familiar with the concept of oxalates very superficially, you might say. But then really looking into it, I think I tapped into something, and there is a whole worldwide community and people who've been doing research in this for decades. But I tapped into something which I see is very, very, very significant, and I see it more and more and more in people in clinical practice. And that is the topic of essentially what you might think of as plant toxins or plant defense mechanisms. Now, a very basic overview is that plants have innate defenses, much like any other living organism. So am I right in thinking that you previously interviewed Paul Saladino?
I had Paul Saladino on the show, yeah.
Right, okay. So your audience are familiar with this concept, right? They're familiar with the concept that plants actually want to protect themselves. Well, oxalate is one of the mechanisms by which plants do that, potentially. And there's also some other ways that oxalate may also benefit plants. But essentially, it's this idea that when we consume certain plant foods, we can acquire or absorb or develop some kind of an accumulation of a toxin which they produce. And this can then go on to spiral down into chronic health conditions of many different sorts. And so that is kind of what led me to research this stuff in a little bit more depth. And I don't claim to be an expert, but I do have a very keen interest in this, and I'm interested in how we can support people who do have these issues.
Yeah. Thank you for that introduction. So, you mentioned something that I wanted to pick on also. Like, I mean, we have been really educated in the last 20 years. Like, the more plants you eat, the healthier you get. Like, I mean, this is like ubiquitous. Like, everybody's saying that. You have your 5 servings or 9 servings or whatever per day of fruits and vegetables. And I've been chronically sick. I had chronic fatigue for like 6 years, and I was going vegetarian, and I was getting vegan and then raw vegan and even more vegetables. And I tried even fruitarian approach, and that didn't really help me, to say the least. And so that's the question I'm asking. Like, is the promise that the more plants we eat, did that actually ever happen? Did it become true? Is this something that really that we can see clinically, or is you already gave a hint, like at least for some people, it's like the opposite is happening.
Yeah, well, there's no doubt that previous therapeutic modalities, for instance, Gerson therapy, which is used very high levels of juices very frequently for things like cancer, I do not dispute that this has worked in certain cases. Likewise, when someone is on, let me give you an example. So many of the low-fat vegan diets, there are certain proponents who've said that they have used this diet, and I know people personally who have used a plant-based diet to actually reverse their diagnosis of cancer. Right now, that's not something I would necessarily recommend, but I know several people who have done that. And so it's no doubt that going on a plant-based diet temporarily can make people feel better. That's one thing. And it can also potentially improve their health temporarily in the short term. I don't dispute that. And now what I think is if we just use our common sense, if we look at the traditional or kind of standard Western diet, which is filtering in more towards the East now. So, all throughout Europe, in certain parts of Asia, we see processed foods, fast foods, essentially foods that have been chemically altered. So when you're on a diet which is primarily processed or chemically altered food, which is pretty much depleted in nutrients, anything is going to be somewhat of an improvement on that, if temporarily, right? So someone goes from a standard diet and they remove all of the processed foods, whether that be going onto a plant-based diet, whether that be going onto any kind of other diet. If it includes whole foods, they're probably going to be increasing their nutrient intake. Okay. Likewise, they're going to be reducing many of the chemicals. So it's like any deviation from the standard processed diet is probably going to provide benefits. And so I think that oftentimes this idea that actually people increasing the plants in their diet, making them feel healthier, I really tend to think that it's actually just reducing the processed foods, which makes them feel good, right?
Yeah, just eating better.
Yeah, just eating more whole foods. So I think that is one of the things which really kind of underlies this this idea that people feel better when they eat lots of plants. But then what we have to understand is that there are numerous financial interests in trying to determine what we should eat as a whole kind of population. So there are billion dollar industries who are producing certain foods who want to affect public policy, food policy, telling us what is healthy and what is not healthy. And it seems that since there has been this kind of, you might call it, crusade against red meat and animal products, when you look at the authorities, generally most of the food authorities are now moving towards telling us that we need to be eating complete plant-based diets or reducing red meat intake, increasing plants. But then you've also got big biotech companies producing things like the Impossible Burger, right? You know about the Impossible Burger?
Sure.
Yeah.
I never had one. I will never have one, but yeah.
I think it's probably, a good idea. But essentially, this is what we're moving towards. And so I honestly believe that actually there are certain, whether it be agencies or individuals right up the top of, say, the food pyramid or whatever, not to get too conspiratorial, but essentially there are people who are making a lot of money off of people moving towards more plant and grain-based diets and away from animal products. Because you see these kind of dietary recommendations, the foods are scalable. You can make a lot of money from a little bit of money. Whereas with animal products, it's kind of difficult to make that much money. Okay. So ultimately, I think that this push towards people going on plant-based diets and whatnot and increasing their plants, I think that there's financial interests involved there. But looking at some of the detrimental effects that people have on plant-based diets, is that what you're wanting to go through? Is how by increasing plants, you're increasing your exposure to these toxins, right?
Exactly. And one of these toxins, I mean, there's lectins, there's phytic acid, there's alkaloids, and one of these toxins are the oxalates, and we want to talk about this. So just quickly, you mentioned like there's an interest in that push into plants, and we just had the movie Game Changers, by James Cameron, who owns a factory for pea protein and stuff like this, So you can see like it's very obvious, like there's a lot of money in that, and people want us to eat plants. And so maybe it's more about financial interest than actually really health. So let's just start from the top. Like, what on earth are oxalates?
Okay, right. So oxalates, the simple term that you can think of it, the base chemical in oxalate is oxalic acid. This is an organic acid. This is found all throughout the plant kingdom. It's made in very small amounts in the human body as well. We make it in the liver. We make oxalate in the liver as part of normal human metabolism. Again, this is in very small amounts. Oxalic acid, the way that you find it in nature, you may find some oxalic acid in its free form, but predominantly it's going to be composed as a oxalate salt. So when I'm talking about oxalate, what this means is oxalic acid is bound very tightly with a certain mineral. Okay, you can think of oxalic acid by itself. It's very corrosive. You can use oxalic acid to it's a corrosive organic acid. If you get it on your skin, it burns. It's got a very high toxicity profile. Pound by pound, it's more toxic than asbestos is. Okay, so oxalic acid is used in chemistry, and it is known as a very kind of well-established toxin. But essentially, the way that you find it predominantly in nature is it's bound with certain minerals. One of those is calcium. Another one is potassium, magnesium. It can bind with zinc, iron. It is used actually as a rust. So you might use it to get rust off of metal, because it binds very strongly with iron. It can actually remove rust from rusty old metal. That you can use it as a cleaning agent. But essentially, when you find it in certain plants, it's going to be in different quantities. Now, like I said before, it's found throughout the whole plant kingdom, but it's found in certain plants more than other plants. So there are certain plant families or certain types of plants, certain types of vegetable and fruit, which contain enormously high amounts of this. Now, it's theorized that this is potentially going to be employed as a defense mechanism by a plant. And the reason for this is that when you find oxalate oxalate or oxalic acid bound with a mineral, such as calcium oxalate, what it does is it forms a very strong tight bond. You can think of it like a magnet. And the way that those crystals precipitate, the mineral crystals, is as very sharp, spiky objects. So you can get various shapes and sizes of oxalate crystals. You can have very, very small nanocrystals, which are capable of traversing through cell membranes and all of these different other kinds of soft tissues. You also have larger crystals. You have these structures called raphides, and these are like long, spiky needles. There's also various different types of hexagonal kind of three-dimensional structures that oxalate can form in. And what this does, you can think of it like shards of glass, okay? And now if you've got a plant, primarily the oxalate is going to be found in the leaves of the plant, and what this may do in nature to protect the plant is actually by providing a mechanical stress. So you think about it, if you if you get a microscope to the leaves of a plant with oxalate, you can find that there are very, very, very sharp crystals. And so if there was some kind of an animal who wanted to eat that plant, when it chews down on the leaves, it liberates these sharp crystals, and what happens is then that then punctures into the soft tissues and can actually cause mechanical stress. Okay, so this is one of the ways that kind of plants stop animals from eating too much of them to then go on to reproduce and kind of protect the other family of that plant. And now what you find is that many people, or many of the foods that we eat in our modern day world, are very high in this particular kind of toxin. Okay, oxalate is extraordinarily high in certain plants such as spinach. Spinach is extraordinarily high. It's high in many of the nuts, many of the seeds, many of the so-called superfoods, Uncas. Okay, so when you're looking at raw cacao powder, cacao dark chocolate is a very high food. We have various kind of Ayurvedic herbs and spices. So, for instance, cinnamon and turmeric, and we have black pepper, and we have many other vegetables. So actually many of the root vegetables, such as sweet potato, the kind of paleo-friendly vegetables, right? Yeah. We see things like cassava is just very high. We have as I said, most nuts and seeds, but there's also certain green leafy vegetables, so such as beet greens or Swiss chard, as I said, spinach. Maybe we could go into where it's found. I think you wanted to go into that a little bit later, but essentially what happens is when this doesn't only apply to animals, we are animals ourselves. So when we consume these foods, then we are liberating these kinds of oxalate crystals. Now, what I haven't said is that oxalate can exist in two main forms. Aside from being free oxalic acid, which you don't find much in plants, it's usually bound very tightly with a mineral. And depending on the depending on the type of mineral is going to determine whether the oxalate salt is soluble or insoluble in water. Okay, so I'll give you an example. Calcium oxalate. Calcium, due to the kind of configuration of the bind between oxalate and calcium, what this means is that calcium is very insoluble in water. Okay, it's very insoluble, so you're not going to absorb much of it. Whereas you also have insoluble insoluble oxalate salts such as potassium and sodium oxalate. So whether the oxalate found in the food is soluble or insoluble is going to determine whether you absorb it into your bloodstream through the intestine. A simple way to look at it is that you can't absorb insoluble oxalate, whereas you can absorb soluble oxalate. And aside from the mechanical stress that the kind of crystals and the sharp spiky structures might be causing to the soft tissues, what I haven't said is that the body can absorb this and accumulate it. And this is really probably the main point of this whole talk, is that unlike other plant toxins that we see in nature, for instance, lectins or phytonutrients, with lectins, if someone has some kind of a digestive issue or some kind of an autoimmune issue and they're reacting to lectins, then simply abstaining from eating lectins is going to resolve that issue fairly quickly. This is where oxalate is so fundamentally different to every single one of the other potentially problematic plant compounds, because we don't react initially to oxalate. Oxalate is actually insidious. So the body accumulates it. The body doesn't accumulate lectins. It doesn't accumulate phytochemicals. It rapidly metabolizes them and it gets rid of them fairly quickly. Oxalate, that doesn't happen. In fact, with oxalate, what happens is long-term chronic exposure of foods which are very, very, very high in oxalates can gradually, basically, you can think of it like the body's burden or the body's total store of oxalate starts to increase because you need to excrete it as you are absorbing it. And unfortunately, your rate of excretion oftentimes is much lower than the rate at which you're eating it if you're eating a very high diet. So the body begins to accumulate this stuff and it stores it in various different tissues. I'm sure this is something we're going to go through in a lot more depth in a minute, but essentially the body is accumulating this stuff and that it needs to get rid of it. And that can be a very gradual process. And so if someone has a problem with these kinds of oxalate stones or oxalate crystals, it can take a very long time to improve their health. Does that kind of answer the question?
Yeah, sure. So yeah, you mentioned oxalates are insidious. They don't act in the same way as lectins do or phytic acid does. It's something that accumulates in the body, and so that would be the next question actually. What are the symptoms? What can we expect? What do you see clinically about it? I had a discussion with a doctor, with an MD, just a few days ago, and we talked about kidney stones. Maybe we can go into that. And he said like, hey, I'm practicing for 30 years, you know. And by the way, he's a proponent of a vegan diet, and I'm practicing for 30 years and I've never seen a kidney stone. So what's the issue with oxalates really?
Well, I mean, that's very interesting. I see people with kidney stones all the time. So maybe it has to do with what kind of people he's attracting in his practice. I don't know. But essentially, when we're looking at oxalates, it can be this kind of abstract concept when we're just talking about the chemistry and the biochemistry. But for people to kind of grok what kind of effects oxalates can have, I'm sure most of your listeners know at least one person who has had or currently has kidney stones, or they may be familiar with the concept of kidney stones. They may have heard of it. Well, you can think of kidney stones as kind of the prototypical oxalate-related health condition, okay? When you look at kidney stones, basically the basic process of what a kidney stone is that certain types of crystals or large stones, which are kind of compounded crystals, deposit in the kidneys. And this can be due to kind of an accumulation of certain mineral compounds in the kidneys, and the kidneys can't necessarily keep up with the burden of the accumulation. They can't pass it. If anyone's passed a kidney stone, it is extraordinarily painful. Well, it turns out that 80% of all kidney stones, whilst you can have certain kidney stones which are primarily calcium phosphate or cysteine kidney stones, 80% of them are calcium oxalate. Okay, so what that means is that the calcium oxalate crystals have built up in the kidneys, and the kidneys can't get rid of them. Now, this can actually lead to like acute renal failure. Okay, you can get a blockage. But generally, it causes lots of oxidative stress and lots of damage to the kidney. So when you're looking at calcium oxalate, or when you hear about oxalate or type it into Google, that is the first thing that's going to come up. Likewise, if you go onto PubMed and you type in calcium oxalate, that is where most of the research is on. And so there is this myth that calcium oxalate, the only problem that it causes in the body is that it causes kidney stones. Whereas that is absolutely, it could not be further from the truth. It really could not be. Right. So the general recommendations for someone with kidney stones is that they should go on a low oxalate diet. So it is acknowledged that a high oxalate diet which is high in certain plants which contain these toxins can eventually accumulate to such an extent that causes the body to accumulate these crystals and cause damage to the kidneys. But what isn't understood is that actually calcium oxalate or oxalate toxicity does not only apply to the kidneys. You see, oxalate crystals can develop or they can accumulate in practically every known organ in the human body. Now, unfortunately, this hasn't been very well characterized. There is some kind of hints that we've gotten through various pieces of the literature, but it turns out that many other people have this kind of issue, but for whatever reason it does not produce kidney stones. They may not have kidney stones, but kidney stones is a very good sign that someone does have oxalate problems. But let's just go through where oxalate can actually deposit and then what kind of symptoms that can produce. So when you absorb oxalate, so oxalate, when you're chowing down on your spinach or you're drinking your spinach smoothie, you're going to be absorbing some of the soluble oxalate and some of the free oxalic acid simply in the soft tissues, in the esophagus, in the stomach. A lot of the oxalate is absorbed in the stomach, but it's also going to be absorbed throughout the intestine. Now, when you absorb it in the intestine, it's going to be going directly to the liver. And remember, oxalic acid is toxic. You can deal with a very small amount at any one given time, but actually when you have a very high amount, it is considered an immune activating substance. So it activates the immune system and your body needs to get rid of it very quickly. So it will go from the liver, it will go to the heart, then it will go to the lungs, then it will go round the body, all throughout the body, and then it will go to the kidneys and be excreted. Okay, so if you've got a high burden of oxalate or a high level of oxalate coming in from the diet, then entering into the bloodstream, it's going to be passing through various tissues before it gets out to the kidney. Okay, so let's just look at some of the organs that oxalate has been found in. Well, what we know is that oxalate can deposit. It's a very strong irritant for the vascular system. Okay, for the vascular system. So you think about it, you're absorbing it from the intestines. It's going out through the bloodstream, through the arterioles, through the capillaries, then out through the veins. And as it's doing so, you think of this stuff as highly corrosive, highly irritant. It can activate the inflammatory process, causing endothelial dysfunction. Endothelial dysfunction is where you're having insults to the blood vessels, causing a localized inflammatory response. It's what occurs in atherosclerosis. Okay, now what's happening is that as oxalate passes through the vascular system, it causes irritation, it causes inflammation to the blood vessels. It can deposit throughout various organs, including the thyroid gland. There's some interesting information. There's one of the studies I was looking at before, it was showing that, I think it was, don't quote me on this, but it was roughly 80% of adults or females over the age of 60 had thyroid or had calcium oxalate stones in their thyroid gland. So you think when this oxalate, when the oxalate crystals, when they deposit in the thyroid gland or when they deposit in any tissue, they're acting on two different levels. They are producing mechanical stress due to their physical properties being sharp. Think of it like a shard of glass. But at the same time, they're also causing biochemical abnormalities. But we won't go into that just yet. But essentially what they are doing when they are depositing in an organ, they are causing inflammation. They're causing oxidative damage. And so in the thyroid gland, they're kind of one of the things that you will find is that people, if they do have oxalate deposition in the thyroid gland, then actually that is going to affect how well they're making thyroid hormones, how well they are able to produce the necessary antioxidants around the thyroid gland, how well they are able to regulate the antibody response in the thyroid gland. So actually, if someone has antibodies in the thyroid gland, you can expect they probably have autoantibodies against that tissue. Okay, that is very common. What you also have, though, is you have it depositing in joints. And when it deposits in joints, it deposits in the cartilage and the soft tissues, the connective tissues around the joints, and it's affecting these things called glycosaminoglycans and proteoglycans, which allow the joints to be, you can think of them as fluid and move over one another in a nice smooth way. And so actually one of the things that you see very often, one of the key symptoms of oxalate problems is unexplained joint pain. Okay, now there is actually a condition in the literature referred to as oxalate-related arthropathy. So it is acknowledged by certain scientists that oxalate can cause symptoms which practically completely mimic arthritis. but there is no autoimmune process going on. So the body is not attacking its own joints like you would see in rheumatoid arthritis. What is actually happening is that the oxalate crystals being deposited, being sharp, being spiky, causing inflammation, causing oxidative stress. These people may have symptoms very similar to kind of asymmetric or symmetric arthritis, but not get the diagnosis. And their doctors may be left thinking, well, okay, you haven't got arthritis, but you've got something and we don't know how to treat it. This is very common. Likewise, you can have it deposit in the muscles. When it goes to the muscles, there you get muscle pain, much like fibromyalgia. In fact, many people I've tested with fibromyalgia actually have very high levels of urinary oxalic acid, okay?
Interesting.
So I think it is a key driver of many people's fibromyalgia, and there are lots of people who find that when they reduce oxalate in the diet, they actually see a benefit with their fibromyalgic pain. But again, much like in the joints, it's causing pain in the muscles. Now, it can go throughout the neurological system, and when it deposits in the nerves, it can actually irritate the nerves, cause damage to the neurological system, and affect how you are processing nerve signals. So you can end up with kind of weird neuropathy symptoms, weird nerve pain, neurological dysfunction kind of thing. This is, again, very common. One thing that I haven't said is that oxalate, like we were talking about before, you think of it like a magnet. It's a magnet for certain minerals. It's a magnet for certain minerals. So when you absorb this stuff, if it's in its insoluble form, has a very high affinity for calcium. So when it's traveling out throughout the bloodstream, you have to understand that in your blood, you have an abundance of minerals. You have iron, you have zinc, you have calcium, phosphate, magnesium, potassium, sodium. So your blood is a dense reservoir of minerals. And if you have oxalic acid, if it's bound with some kind of, say it's bound with potassium and it's traveling through the blood, because of its kind of, you think of it like its dense negative charge, it has a very high, it really likes calcium. So what it will do is it will tend towards binding with calcium over any other mineral. And this is how you're getting these stones precipitate in certain tissues, is because you have the flow of blood. If you have elevated soluble oxalate or free oxalic acid in the blood, then you are going to end up with the transfer of the oxalate towards calcium, and then as that becomes insoluble, that is going to precipitate and stick in various tissues. But essentially, oxalate has been related, or to come back to your question, in short, the types of health conditions, generally what we are seeing is pain. We are seeing any joint pain. If we look at the kind of the transport of oxalate, we know it's important in kidney function and kidney stones. So if someone's had kidney stones and they are oxalate related, which most of the time they are, generally they have a problem with this kind of toxin. But what you also see is that as the kidneys are excreting this stuff, as it's excreting it, it needs to go into the bladder and then out through the urinary tract. Okay, so one of the kind of primary ways that this was publicized to the public was an individual who's doing research on vulvar pain, or a condition called vulvodynia. Vulvodynia is essentially where the soft tissues around the genitalia of the vagina in a female are unexplainably causing pain. So this can feel like shards of glass in the labia or in the vagina or on the outside of the vagina, and cause women lots of pain. And there's not really that many explanations for why it occurs. Well, what this one individual who actually created the Vulva Pain Foundation, she found that actually oxalates were highly implicated in this condition, and when she went on a low oxalate diet, that actually it improved it wonderfully. And so what is happening is, as oxalate stones or crystals, nanocrystals and things are being passed out through the urine, then you're having as I said, it's corrosive. So what it's doing is it's damaging the urinary tract. You can cause micro tears in the urinary tract. You can cause micro tears in the bladder. So one of the things that you see very often is people having unexplained UTIs, so chronic urinary tract infections. Or what you also see is that people have UTI-like symptoms such as interstitial cystitis, but there is no acknowledgeable infection. They may go to the doctor again and again, and they will culture for some kind of a bacteria, usually E. coli, yet there will be no bacteria which is grown. And so the doctor may prophylactically prescribe antibiotics to improve that, but they will not see a benefit, because the problem is not necessarily an infection per se. It is that you have these crystals coming out of the urinary tract, carving away at the bladder, getting lodged in the bladder, and then also coming down and penetrating into the soft tissues, causing pain, feeling like shards of glass, causing kind of frequent urination, blood in the urine, painful urination, all of these kind of urinary symptoms. It can also affect the gut as well, though, and this is something important. As I said before, most of the oxalate is absorbed in the intestines, but you also have some being absorbed in the stomach. But as it's lodging into the soft tissues throughout the esophagus and in the upper stomach, you can actually have what is referred to, or what it kind of mimics like a neurological impairment of the sphincters. Okay, so when you have neurological impairment of the enteric nervous system, the enteric nerves can't fire properly. They're unable to fire. And so essentially you can develop things like acid reflux or dysmotility, because what it's doing is it's temporarily paralyzing the nervous system in the gut, which is responsible for contracting and making sure all of the sphincters are closed at the right time, allowing you to gastric empty, so empty the contents of the stomach into the upper intestine, and then also is involved in how well you're propelling food throughout the intestine to effectively digest it and eliminate it in proper ways. So again, I could talk for hours on just this one topic, but essentially it has been found to lodge into the aorta, for instance, in the heart. It's been found in the heart. It can disrupt mineral balance. Remember, I said that it was a mineral chelator. So it's a magnet for certain minerals. And for your cells to properly function, especially nerves, there's something called the sodium-potassium pump. So the balance of minerals inside and outside the cell is extraordinarily important for how the cell is passing messages, but also how the cell is actually functioning. And so what we see in kind of in organs which are governed by the nervous system, when there is excess oxalate present, it's affecting the mineral balance inside and outside of the cells, which is then going on to affect how well messages are sent from, say, the brain through the autonomic nervous system to the organs such as the heart. And you can end up with kind of weird type arrhythmias and other kinds of unexplainable abnormalities related to certain organ function. I'll just reel off a couple of other health conditions which have been found to be associated with oxalate, because it is very interesting. It has been associated with potentially with autism, so it can lodge in the brain, can lodge behind the eyes, can come out of the skin. It's been found in the thyroid gland, as I've said, but it's also been found to disrupt the liver function, liver metabolism, in the kidneys, as we see. Again, it's been associated in the gut as well. You can think of these sharp crystals traveling through the gut, being very corrosive, causing mechanical stress, actually tearing away at the gut lining. So it has been implicated in peptic ulcers, in Crohn's disease, and many different kinds of gut dysfunction. I find that when people reduce oxalates in the diet, their guts generally tend to improve significantly. But also
could that be a reason for leaky gut?
Well, indeed, yeah. What has been found in the kidneys is to disrupt certain proteins called claudin. Now, these are effectively the same proteins which are responsible for maintaining the tight junctions in the intestine, along with zonulin. So actually, what we find is that it does affect those kind of proteins in the kidney. What I suspect is that it does potentially cause leaky gut as well when you have excess present. Now, there's an important thing to note here, though, is that generally, whilst oxalate can be implicated in kind of causing gut issues, I think elevated oxalate absorption is more likely to be a consequence of gut issues. So what I haven't spoken about, I've spoken about how kind of you're absorbing it and all of this kind of stuff. essentially, not everyone is going to be absorbing the same amount. So one person eats.
Elliot, before we go into absorption, let's have a break here. Because we already that was quite a blast. That's so interesting to listen to you, and I'm actually learning a lot, and I already have dove into this topic quite a bit. So you mentioned like a million things. Like there's like the question I'm asking, like, is there anything that's not related or could not be related to oxalates? You seem to have mentioned like every tissue, every function in the body.
Yeah, right. I'm going to be honest. A lot of understanding of oxalate problems comes from literature, either on kidney stones, but actually one of the most important areas of literature is on a condition called primary hyperoxaluria. So you remember I was saying that the body can actually make its own oxalates under certain conditions in the liver. Well, some people have a very rare genetic defect, which means that they produce excess amounts all of the time. Okay. Now, what happens in these individuals is we see oxalate deposits in almost every single tissue, or many different tissues. So what we can surmise from that is that if someone has this kind of issue of a very high oxalate diet, they are absorbing excessive amounts through a condition called enteric hyperoxaluria, then essentially what you are ending up with is, I personally believe, and many other people believe, that you can produce a very similar situation. And so to answer your question, I don't think there is anything that is not potentially related to oxalate, because if you look at this, it's an inherent toxin, right? Now, it's not a toxin in the sense of mercury or lead or cadmium, but essentially, when in high amounts, it is extremely toxic. And so if it gets to one of your tissues, then it is inevitably going to cause stress and damage. It's an under-researched topic, and I don't like to paint everything with the same brush. What I will say is that I'm confident that it could probably contribute to any known health condition.
Okay, all right. So we call it a day for this part of the episode, and we're gonna talk more about it and going to dive into the cell, mitochondria, and of course we're going to dive into like more the practical aspects of it, which foods contain it, and what to do, can we mitigate it, and everything else. So thank you for being on the show, and yeah, see you back in the next part. Thank you, Elliot.
Excellent.
Hello and welcome to the Bio360 show. My name is Unkas Gamika, and today I'm going to talk with Elliot Overton about oxalates. Hi, Elliot.
Hello.
So this is the second part of our interview, and yeah, you just had a blast in the first part of this interview. Like, I just asked, like, what can they do in the body, and you just mentioned like almost everything that's available. You have touched a little bit on the cells and the potassium pumps and everything. Like, is there even like some damage in the cell itself, like to the mitochondria, for example?
Yeah, indeed. So we were talking about how oxalate, when it's bound with a mineral, so you're looking at calcium oxalate, such as a insoluble calcium oxalate crystal. What this does is precipitates in the tissue. It can cause mechanical stress, causes mechanical damage, right? So it's working on a mechanical front. It can cause kind of irritation and inflammation that way. You think of it a bit like a shard of glass. Whereas you also have these things called nanocrystals, okay? Nanocrystals, and you have slightly larger oxalate structures as well. So you see the cells have transporters on the cell membranes, and there's various different types, but essentially oxalate can be getting into the cells through certain transporters. And then when it gets into the cells, it can wreak havoc on a biochemical front as well. What we're talking about is inhibiting or activating or influencing certain processes which occur inside cells, all right? Now, as I said before, you have these transporters on the cell membranes which are shunting oxalate in and out of the cell. You also have nanocrystals which are very, very, very small. And what they can do is directly pierce through cell membranes. Okay, now when you have excess of those, what they've been shown to do is effectively puncture cells. So you can puncture holes into the cell membrane, and that causes all kinds of different problems. It can actually lead to cell death. But when you have elevated oxalates inside cells, what is occurring is it's activating or it's inhibiting various enzymes. So an enzyme is what converts one thing to another thing. Okay, one of those, or a class or family of those enzymes, include what we call the carboxylase enzymes. Now, these are generally involved in energy metabolism. You have one which is referred to as pyruvate carboxylase. This is involving certain chemicals involved in something called the Krebs cycle. Okay, and this is how we're effectively making energy in the mitochondria. So what oxalate can do is it can, you think of it like it can dock onto this enzyme, this pyruvate carboxylase enzyme. And this enzyme is usually dependent on a vitamin called biotin. Biotin is otherwise referred to as vitamin H or vitamin B7. It's found in very high levels in egg yolks and liver and in a couple of other foods. Biotin is, what's happening here is that when you have this docking onto these enzymes, these carboxylase enzymes, which are dependent on this vitamin, what you can end up doing is producing what mimics a functional biotin deficiency. So someone can have enough biotin around, but essentially, if you've got too much oxalate, which is docking onto the enzymes which use biotin, you can basically take the place of biotin and stop it from working. And so you can have various disruptions in how the cells are actually making energy. Okay, now if you know, I'm sure many of your kind of guests in the past on this podcast have spoken about the mitochondria or mitochondrial function. Essentially, it's the powerhouse of the energy. And there's a lot of research today to demonstrate that in most chronic health conditions that we see, aside from kind of acute injuries, when you're looking at something like cancer, when you're looking at diabetes, any kind of autoimmune condition, any kind of neurological condition such as Alzheimer's or whatever, you see at its root, it tends to be a mitochondrial dysfunction, which is primarily driving the issue. So there are certain researchers who would say that mitochondrial dysfunction is the cause or one of the primary causes of all chronic health conditions or all chronic illness. Well, to understand why that happens in a very simple way is that the basic concept is that your cells need energy to do everything that they can do. Okay, you need energy. You need energy to detoxify. You need energy to repair, to make new tissues, to make new cells. Okay, this is extraordinarily important. And so when you start messing with mitochondrial function through something like a mitochondrial toxin like oxalate, then you run across lots of different problems. So like I said, it can kind of mimic certain deficiencies, one of those being biotin. What it can also do is lodge onto or disrupt the various complexes in the mitochondria. To make energy, you run essentially substrate through various different, what they call complexes, 1, 2, 3, 4. And this helps to make ATP, which is the cellular form of energy. But what you can have is when you have disruptions or inhibitions of certain complexes in those enzymes, you end up with a lack of ATP in the form of energy, and you end up with excessive oxidative stress in the form of ROS. So ROS, reactive oxygen species, this is leading to free radical damage. So we see that oxalate is not only acting on a mechanical level, it's also affecting how cells make energy. It also, not only does it affect the mitochondria, though, it's really interesting. It can affect practically every known organelle. So an organelle inside the cell is like the various different machines, the machines inside the cells which help them to function. It can puncture these things called lysosomes, right? And lysosomes, without going too mechanistic, because you can focus on the minute details, but actually looking at how it appears in real life is important. But I like the minutia. So with these lysosomes are essentially organelles inside the cells, which are responsible for degrading damaged parts of proteins in damaged parts of the cells that you don't need any longer or don't work properly. And the way that they do this is they contain these things called hydrolytic enzymes. And hydrolytic enzymes, it's like a hydrochloric acid. It's very acidic, and it can essentially break down various parts of cells. Okay, so that's good in a normal context. But what oxalate can do when you have these very sharp crystals, again, think of it like you smash a glass, you produce loads of minute shards of glass, and then you rub it against your arm. It's going to cause damage, right? It's going to cause cuts and abrasions. was inside cells, this is essentially the same thing that happens. So you have these abrasions and you have these spiky structures which can basically puncture these lysosomes that I was talking about. You end up with a release of these hydrolytic enzymes and essentially digesting healthy portions of the cell, healthy organelles, digesting the cell membranes. Essentially, you can cause two methods of cell death by doing this. You can cause necrosis and you can also cause apoptosis. Two ways in which your cells essentially burst. Now, aside from that, because you have this stress response inside the cells, it's activating this. You think of it a bit like a protein machinery, which is responsible for modulating immune responses. So you activate something called the inflammasome. Okay, the inflammasome has been shown to be disrupted or essentially overactivated in many different kinds of chronic autoimmune conditions as well. Okay, so this is where oxalate potentially ties to autoimmunity. With autoimmunity, there is this activation of this inflammasome, and if you are not identifying the key trigger for what is activating the immune system, then it's very difficult to resolve any autoimmune condition. Now, it turns out that whilst there's loads of different things which can activate this kind of particular immune response, being chemicals or EMFs or, lectins, all of this kind of stuff, oxalate is also a key driver in this process. So here we see that oxalate, not only can it kind of cause joint pain and brain fog and thyroid issues and other kind of intra-organ issues, but it's also potentially going to be driving systemic autoimmunity and a systemic immune dysfunction due to the fact that it is activating an intracellular inflammatory, or you can think of it like a danger response. Okay, does that make sense?
Yeah, makes a lot of sense. Definitely. Well, at the moment we are having this interview, I'm actually running a series of interviews about the topic of chronic disease, especially chronic fatigue, fatigue in general, fibromyalgia, and this kind of stuff. And I think we're kind of really missing that kind of interview. You got to learn German, man. So, because that could be like something like completely overseen. I mean, because we don't have a lot of awareness. In Germany, there's not a lot of awareness. And maybe there's some mitochondrial dysfunction, which is at the base, as you said, of like ton of, if not all chronic diseases. There's a lot of common sense about that. And meaning anybody with like unexplained fatigue and this kind of conditions that I experience, and I try to do we touch later on that, like how I try to improve my health with increasing oxalates without knowing it. But yeah, people might be affected of that in all sorts of levels, inflammatory responses, intracellular, extracellular issues in the gut, in the thyroid. Oh my goodness, all this leads to fatigue, to inflammation, to anxiety, to a lot of issues, really. So. You mentioned, or just a question, like talk about the liver a little bit, because from my knowledge, the liver actually produces oxalates. And so that's part of the question. The other part would be like, can we actually detox oxalates?
Right. Okay. So, like I said before, right, the liver is the hub of a biochemical pathway called the glyoxylate pathway. Okay. Now, what this is doing is this is taking various precursors. You can have some coming from certain sugars and carbohydrates, such as fructose, other types of carbohydrate metabolism, often seen in diabetes. You get elevated levels of something called methylglyoxal. Various of these precursors can be routed down towards a product called glyoxal. You can also have certain amino acids such as hydroxyproline or glycine. These can be routed towards glyoxal. Now, glyoxal is the primary precursor for oxalate in the liver. So essentially, under certain conditions, the liver, well, really, in any healthy individual, you are going to have a small amount of oxalate which is being produced through this pathway. It's just a natural, normal byproduct, a metabolic byproduct of normal physiology. And so humans are always going to be producing a very small amount, okay? The problem is that under certain conditions, particularly 3 main conditions that I am personally aware of, 2 which are theoretically plausible, 1 which is very well established, is that when the liver is under oxidative stress, or when the cells are under oxidative stress, you are producing more of a precursor called methyl glyoxal, which is producing this thing called glyoxal. Essentially, when the liver is under oxidative stress, when we are deficient in certain nutrients, primarily the 2 B vitamins, which has been characterized in the animal literature, is not very well established in the human literature, mainly because I think it hasn't been addressed. But if you're deficient in vitamin B6 or vitamin B1, because of where they sit in the pathways, you can end up with elevated oxalate production in the liver, actually contributing towards the overall oxalate load. So remember I said that there is a genetic condition referred to as primary hyperoxaluria. Okay, primary hyperoxaluria is essentially where the enzymes involved in the glyoxylate pathway, you can have 3 types. The enzymes involved in the glyoxylate pathway are not functioning correctly, and so you end up with elevated levels of oxalate being produced, and then that oxalate is basically being released into the bloodstream and then traveling throughout the whole of the body. And we see in the literature on primary hyperoxaluria that actually oxalate can then deposit in practically every known tissue, and it's coming out of the eyes, it's coming out the ears, out the skin, out the mouth, out the anus, urine, all of this kind of stuff. So it's a very horrible condition. Now, again, we have this kind of dogma in the literature and the science community that this is only a problem for people who have this genetic condition, and that for anyone else, this is not an issue. But in our modern world, especially with Western diets, well, with all of the different kind of exposures that we have in our modern world, we live in a condition, in a situation where we are being bombarded by stuff which is causing oxidative stress. That's one thing. We also have very high, there's a term called high calorie malnutrition. So we're having lots of empty calories, which means that we're getting lots of protein, fat, and carbohydrate, but actually they are often depleting micronutrients which are needed to process those. So we can end up depleting ourselves in certain B vitamins which are involved in this pathway, B1 and B6. And so if you end up with a condition where you are under oxidative stress, where you have a B1 deficiency, which is really common, where you have a B6 deficiency, which is, again is quite common with these people, then actually you can end up with an endogenous production, and that can contribute to the overall load. So really they are 2 kind of separate things, but the way that they interlink is that someone on a high oxalate diet, because of the route of oxalate absorption, it's going to the liver first of all, it's possible that actually oxalate, if you have a high burden of it in the liver, it's causing oxidative stress. Oxalate is potentially depleting B6, it's potentially depleting B1. So then you end up with a condition, if you go on for long enough with a very high oxalate diet, there's a good chance that you could actually cause your liver to make more oxalates.
So it goes both ways then with the B vitamins.
Basically, yeah, it goes both ways. And I mean, it's important just to interject here, because this is something that I haven't spoken about just yet. The absorption. So we're talking about kind of a high oxalate diet. You can have 2 different individuals. You feed one a very high oxalate diet and you feed the other one the same diet. The amount that is absorbed is going to differ between different people. And there's several different factors which govern this. You spoke about before about a leaky gut. Okay, so a leaky gut, you think about it, if the intestinal lining is perpetually kind of opened or is leaky, so to speak, and I'm sure your listeners understand this, if you have this leaky gut condition, then essentially what this is a free pass for oxalate coming from the gut, particularly soluble oxalate, but also some calcium oxalate can then get through the gut lining if it's not functioning properly. So if someone has a gut issue, and gut issues are so common in our modern world, leaky gut is so common, with the Wi-Fi, with the EMF, with the blue light, with the chemicals, with the diets, with the lack of exercise, with all of this different stuff, it's causing intestinal permeability. So I think that in our modern world, people are a lot more susceptible to absorbing more oxalate. Now, if you look at the literature, there's also couple of other factors which have been involved or which have been implicated in someone's absorption of oxalate, and that is going to be whether they have a history of antibiotic use. So for instance, there are certain microbes which are said to degrade oxalates so they can protect us from absorbing too much, and this is potentially how certain traditional cultures have maintained a very high oxalate diet in the past, but their gut microbes may be a certain composition whereby they can protect the body from it. Okay, do you follow? So actually, the gut.
Yeah. So you're saying there's bacteria in the gut that actually kind of transforms the oxalates to something, and so traditionally that has been something that could protect us. But is that still the case?
Well, yeah, that's exactly the point. There's Oxalobacter. There's certain other species which they have enzymes which degrade oxalate, so it means that you don't absorb it, and that is protective. But again, in our modern world, you think about how many people have gone through so many rounds of antibiotic use in their young periods. You think the pesticides such as glyphosate. I'm sure you're familiar with glyphosate. That stuff is wholly toxic.
I've definitely signed up on the show.
Wow, yeah, okay. I've interviewed her myself personally. She's a genius. But she talks about how there is a very strong connection between glyphosate and oxalate. I actually did a video on this. Glyphosate is selectively killing off those certain bacteria which help us to degrade that stuff, right? So if you end up with a condition where you're loaded with pesticides, you're loaded with you've got microbial dysbiosis in the gut, and you've got leaky gut maybe because of that or something else, then you are going to be a lot more predisposed toward absorbing more. Now, there are certain things which can also prevent us from absorbing oxalate. So one of those is actually certain minerals. Okay, so one of those is calcium. If you remember me saying, oxalate really likes to bind with calcium. It's like a very high affinity over other minerals. So if oxalate's bound with potassium or magnesium, it is going to be drawn towards calcium. It much prefers that. Okay, and when it binds with calcium, it's insoluble, which means that providing your gut is in a relatively okay state, you're not going to absorb that oxalate. So therefore, dietary calcium is considered a protective factor against absorbing excess. And this is where we can look at therapies in terms of how we can prevent oxalate problems and how we'll talk about this a little bit later. But you think of the amount of people these days, I myself am included, who for whatever reason have built up some kind of an immune intolerance to dairy products, right? So many people are on a dairy-free diet now, okay? They're on a dairy-free diet, but at the same time, they include a bunch of oxalate foods because they think it's really healthy. So they might give up dairy product and replace it. What do they replace it with? Almond milk, okay? Almond milk. Almond milk is absolutely sky high. So what you're doing there is you're removing dairy, which is one of the highest.
I did that for my daughter not a long time ago.
It's so
like sprouting it, I mean, soaking it and doing it myself, the almond milk and everything, Yeah, we come later to that because that's so fascinating, all those superfoods and everything. Yeah, keep on going.
Yeah, well, I did it myself. And it's the same story. We're told that, okay, due to whatever reason, we have problems with dairy. I think probably because of some kind of cross-reactivity, chemicals, vaccines, whatever it is. But we develop an issue with dairy, and so actually a large source of calcium is then gone out of our diet. And the only forms of other calcium, we're told that we should be eating spinach, for instance, because spinach is a good form of calcium. But actually, when you look at the composition of spinach, it's one of the highest oxalate foods. So the calcium is so tightly bound with oxalate in that food that you're not going to absorb any of the calcium anyway. It's a joke.
Yeah, okay. And are you saying that having a high oxalate diet kind of could lead to some sort of mineral deficiency?
Well, that's exactly what happens. Okay, that is exactly what we see. Well, just to what I was saying before, the dietary calcium is protective against it, and if we don't have that, then that is a problem. So when we are absorbing oxalate, then if we don't have the gut bacteria, if we don't have the calcium, there's various things which disrupt the gut. We're absorbing higher amounts of oxalate. When it gets into the blood, if it's not precipitating in tissues, yeah, we can clear it out through the kidneys. But unfortunately, when we're clearing it out through the kidneys, it is inevitably going to be taking minerals from us. Okay, it binds very tightly to minerals. And so, yeah, it might get into the blood. it may not cause a kidney stone, but at the same time, it's going to be tightly bound with things like magnesium and potassium, okay? So it can actually cause us to waste certain minerals. And so often you find that actually it can cause mineral imbalances in people. And this is a key thing that you can actually do, or that you can focus on in terms of what you can do about it. Does that answer the question?
Yeah, sure. Okay, so before we talk about what we can do about it and how to mitigate maybe some of the issues, now we're going to move on some more practical things. Like you already mentioned quite a few things. Let's talk about the superfoods and where actually we can find the oxalates.
Right, okay. So in terms of the foods, there's lots of conflicting information online. There are various health...
Why is that?
I mean, I think it's because, now, again, I'm no expert in this field, but as per my understanding, discussions with kind of Susan Owens and whatnot, who really is an expert, I think it has to do with testing methods. Okay, so previously, the way that we've identified oxalate in foods has been kind of, you can think of it as kind of crude testing methods, which weren't necessarily the most accurate. And oxalate, we started measuring it because it was an established toxin, in the 1700s, or 1776, I think it was first kind of discovered as an issue. But throughout the kind of past century, they've been measuring it, and you've gotten conflicting results. And so certain foods which have been said to be high have actually turned out to be low, and other foods which have been said to be low have actually turned out to be high, because the quality of the testing is actually improved, because the composition of the oxalate in different foods is different. Okay, so ultimately, there are certain kind of websites that you'll go on which just give a very blanket statement of what foods are high and what foods are low. And oftentimes they are incorrect, or they're not the most accurate or the most up to date. So actually the list that I find to be the most reliable is the one which is available on the Trying Low Oxalates group on Facebook. And I think that a lot of the testing has been done independently, but it's also been taken from very up-to-date sources. A lot of it's derived from independent testing that I think was done by the Vulva Pain Foundation, but there's also many other kind of resources there which have been kind of independently verified. So it turns out that certain types of foods like coffee, if you go online, you'll be told that coffee is high in oxalate. But actually, the recent testing methods have kind of disproven that. Coffee is not high in oxalate. It's not an issue per se. But there are certain foods which are extraordinarily high. So we've spoken about the very basic ones, okay? So for instance, you have dark chocolate, which is said to be a superfood. You have, in fact, here's an interesting one, is certain fruits, okay? So most fruits are relatively okay, but you have things like star fruit, you have kiwi fruit, you have clementines, you have a couple of different fruits which are, particularly the berries. Many of the berries contain very high levels, such as blackberries, or certain types of blueberries, whereas other types are okay. And this is where it gets kind of important to differentiate, because certain types of vegetables, certain families of vegetables can contain high levels, whereas other families which fall into the same category, such as kale, you can have purple kale, which is fine, whereas ordinary kale is moderately high. Okay, so it can get quite confusing in terms of exactly what is very high and what is low. And so that's why it's important to kind of cross-reference, if you want to know the exact details, to cross-reference with the available resources online. But essentially, many of the staples which are found in gluten-free diets, okay, and this is where it gets kind of difficult or kind of problematic. People who follow gluten-free, dairy-free diets, which is really common, what they end up doing is they end up replacing wheat. Wheat is relatively high, but they end up replacing wheat with something like almond flour. Okay, now
wheat is high in oxalates?
Yeah, wheat is quite high. Okay,
oh, I didn't know that.
Yeah.
Okay.
Wheat and most grains are quite high. Most grains are quite high. You find the odd thing which is not, like for instance chickpeas. Chickpea flour is relatively low oxalate, but most of the grains are quite high. Many of the gluten-free grains are actually higher than wheat, if I remember correctly. So you have people going on gluten-free, dairy-free diets. So they remove the calcium, which is protective, and then what they do is they also massively increase really high oxalate foods to make things like gluten-free breads. So for instance, you have things like almond flour. Almond flour is so high that you would not believe. So when you cut out bread or on ketogenic diets, if you know people who follow ketogenic diets, what they do is to replace the bread portion of their diet, they end up using very high oxalate foods to replace those things. So almond flour, any kind of nut flour, is just unbelievably high. You also have things like certain nuts, as I said, like peanuts, but you have many of the so-called healthy herbs and spices like parsley or turmeric or cinnamon. And whilst what we do is we see that these things have some kind of nutritional or medicinal properties, such as in Ayurvedic medicine, we see, oh, they use turmeric and they use cinnamon, and this is beneficial. So what we do in the West is we put 2 tablespoons worth in a smoothie and have that on a daily basis. and that's just not what they did in those cultures. They used it as medicine. Yeah. And it can be used as medicine. But what we do is we take it to the extreme. We assume that, oh, more is always better, right? And it doesn't work like that. And so actually what we do is we end up piling things like turmeric and cinnamon into our smoothies, and we get a massive dose. Now, if you look at a green smoothie, which contains something like turmeric, cinnamon, almond milk, maybe some ground almonds, some juiced spinach, some berries, some raw cacao powder. Okay, that's a kind of typical recipe for a vegan smoothie, right? Or even for a keto smoothie. That is what you might find. Well, the recommended daily intake for oxalate consumption is around 150 milligrams per day, right? Whereas in one of those smoothies, you could easily top 1.3 grams. Okay, over 10 times the amount of the daily recommended intake in one smoothie. And that is aside from all of the other, the sweet potatoes, the potatoes, something I haven't spoken about. So I said sweet potato is high, but also potato and many other root vegetables. And then you have, like I said about kiwi, what a lot of people find with kiwi, and I personally found this myself, is that many people find that when they eat kiwi fruits, they actually get like a fuzzy feeling in the mouth, or like a kind of an abrasive kind of stinging sensation on their tongue. Do you ever get that?
Yeah, I get it all the time. Yes, I got it as a child. My daughter gets it, and seems to be people accept that. That's normal, But these are the oxalates like getting into the tissue, right?
That is exactly it. That is the oxalate being liberated, and I never knew this. But again, that's oxalate being liberated and actually puncturing, causing microabrasions to your mouth, right? So it's really problematic. Really, the saddest thing, though, I would say, is that many of the other foods, we don't get an immediate response. We don't get told. Our body doesn't know when this happens.
Why is that? Why don't I react to cacao, which I was over consuming like crazy?
I think it has to do with the ratio of soluble, insoluble, and free oxalic acid, right? So I think that, don't quote me on this because I'm not entirely sure, but I would imagine it has to do with the type of oxalate which is found in the kiwi fruit and why that's potentially more liberated, okay, than other types. But simply just because you don't get an immediate response from cacao or some other kind of food does not mean that it's not causing you a problem. And that actually, this is why I think it's so dangerous, high oxalate diets are, and why I try to get as much information as I can about them. They are so insidious in that people oftentimes don't get immediate responses, but it goes under the radar. And you only start seeing that you've got issues with it when it's too late, when you've already accumulated quite a lot of it. And it takes a long time to get rid of. But on some of the foods, if we, again, like one of the actual the highest foods in nature, particularly in the northern hemisphere where we grow, is rhubarb, right? And rhubarb, there have been cases of individuals who have eaten too much raw rhubarb and actually developed like acute kidney failure. Okay, so you can the tangy flavor in rhubarb is actually attributed to its very high level of oxalate, and so the high oxalic acid in the rhubarb. It's why it's very important to cook it and to have it very ripe. But even then, it's extraordinarily high. What we have to understand about many of these foods this is where kind of seasonal eating comes in, is that 100 years ago or so, before we had international export, we would not have had access to things like almonds, these tropical fruits, these other kind of tropical foods like cacao and other kind of herbs and spices. We would not have had access to them for, I mean, well, before international export, we didn't have them, right? We never used to eat these foods, and we're told that these are super healthy foods and that we should be getting lots of them. But actually, you don't see them in nature where we live, right? So I think that we have less capability to be able to process them effectively. There's also the issue of seasonality. So actually, Sally Norton has written a very good paper. It's called like Lost Seasonality and the Overconsumption of Vegetables, and it's that essentially in the supermarket where we are now, what we can do is we can go there and get all these foods all year round because we grow them in an artificial like manner, and we can get foods that don't grow in our local environment at all times of year. Like you can get strawberries in December when they just simply don't grow in Germany, or they don't grow in the UK. You don't get them. You get them in short bursts throughout the year. So for instance, rhubarb only has a very short season of like 1 or 2 months. So what would be happening is that you would be eating a very small portion of this at a certain time of year, but then throughout the rest of the year, your body would have a rest from eating this high amount. Whereas, so it's like maybe you could have a better capacity to cope with the damage that it's causing, because it's like temporary periods of eating lots, then eating little, then eating lots and eating little. So you give your body a break. Whereas in our modern world, what we see is that people eat these non-seasonal foods all year round, and the body is really not equipped to cope with that. We are not designed to deal with constant influx of very high oxalate foods all of the time. Okay.
Yeah. Plus, coming from our ancestors, there's a huge discussion about that, what we actually ate. But I'm much more on the page with like people like Paul Saladino, that I think that we ate a lot of animal foods. When we had like big ruminants everywhere. Because they're so easy to catch and they give such an enormous return of investment actually from the energy you're putting in, and you're getting so many calories out and so many nutrients. And so we kind of came from that, and then now ate starting 10,000-12,000 years ago, starting to eat grains. And now we got in the last 100 years, you have this international food, and we're getting everything from everywhere all the time. So it's just getting worse and worse. And so the availability or the amount of oxalates we found in our diet is just like uncompared to what would happen like 15,000 years ago.
Yeah, exactly. So you have it's like it's coming from all fronts there. So you have, like you just said, this an enormously high, unnaturally high influx of oxalates, but then you also have a less of an ability to process that, because you have the things like the antibiotics, the toxins, the gut disruptors, the things which affect how well we can process that. So it's like both things kind of set up an individual to be absorbing a lot of this, accumulating a lot of this, and then developing health problems from that. Now, on the topics of foods which contain it, it's important to note that there are actually a lot of plant foods which are very kind of low in oxalate as well. So, for instance, typically many of the brassica vegetables like cabbage, broccoli, these kinds of things are relatively low. You also have certain safe vegetables like lettuce, for instance. Most salad greens are low, other than spinach and beet greens, actually, and Swiss chard. Most of them are actually negligible. So, for instance, cucumber, lettuce, these things are not going to be contributing towards issues. Certain root vegetables are actually tolerable as well, such as winter squash, for instance. This stuff, although it has a bunch of enzyme inhibitors,
and it has a lot of lectins.
Yeah, exactly.
I had a winter squash the other day, and so I had a full one, like maybe a little bit too much, but man, I looked like a fucking inflated frog the next day. Really. I could demonstrate it, just to just show you what lectins and these kind of anti-nutrients do with my body. And yeah, maybe we can dive into that a little bit more in like the third part, because we're already talking for quite a bit. So let's call it a day on this part, and then keep talking about all these foods and how we kind of made it even worse. Like I said, like we came from eating animal foods and then eating grains and now eating international food, but then we think that these are the healthy foods, and we completely overdo it. And I want to share a little bit like how I did that. Thank you for being on the show, man. Goodbye. Hello and welcome to the Bio360 show. This is the third part of my interview with Elliot Overton, and we talk in oxalates. Hi, Elliot.
Hello, Uncas. Thanks for having me on.
Thanks for being here. And we've already dove deep into the topic, and you just mentioned, like, we talked a little bit about like all these foods that have a lot of oxalates and to amounts that are actually quite dangerous. So that would lead later to the question of like how toxic are they, or what is a toxic amount. But before we go into that, I want to just share a little bit, because everything you mentioned, like all the foods you mentioned, like cinnamon, bees, Swiss chard, spinach, cacao, turmeric, tea, blueberries, blackberries. I have been consuming this because I was sick. I had chronic fatigue, and I wanted to get better. So I wanted to refine my diet. I wanted to, all the time I learned something new about it. Oh, there's these antioxidants in that kind of fruit, and or there's bad things, like we have gluten and stuff like that. So I from my muesli, from my granola, I shifted to eating buckwheat. I sprouted it, and I put cacao on top of it, and I put almond milk in it. So that was like the pinnacle of health. This was just nothing better. And then I was like, at some point I was doing smoothies. So in my smoothies there would go like huge amounts of turmeric. There would be cacao in it. There would be like everything we mentioned. There would be almonds in it, and I would eat almonds like crazy. And for many years, I mean, I'm on this health journey for quite a bit, but for many years I would like look into the mirror in the morning and I say like, oh my God, I'm really trying to do everything in a really good, I'm very disciplined, I'm doing a lot of effort for my health, yet I'm looking fucking shit, And so now I'm kind of on a, let's call it a very reduced diet. So not getting a lot of this stuff, and I can see the difference. I can feel the difference. So there's a lot of things that actually affecting me negatively, and I think oxalates definitely play a role in it. It's hard to tell it apart, because there's in many foods we have several anti-nutrients, that might affecting us. So and maybe you can talk about this, like the toxic amounts, like, because there's a deadly dose to it, right? Deathly.
Yeah. First of all, I just want to say, I'm sorry that you had to go through that, Uncas. It seems to be just a recurring theme, right? It's a recurring theme. And it was the same for myself as well. You're following all of what you think is meant to be the healthiest way of eating, and you put all of your resources into it. And it's the same. I mean, I studied nutrition, and I was aiming to get 10 cups of green leafy vegetables, spinach, and all of this stuff in every single day, right? And it did not provide the results. Thankfully, touch wood, I didn't get really sick, but I work with a lot of people, and it's a recurring kind of story. People, the more plant foods they eat, the more oxalates they eat, the worse they actually become. So it seems to be just this recurring theme that is so common now, so common, especially. And so it's really important that, you're getting the word out there, because people need to know about this stuff. Now, on the toxic dose of oxalate is toxic. Oxalic acid is an established toxin. I think it was the first ever proper toxin studied in toxicology studies. And I think the acute toxic dose is, if I remember correctly, I think it's like 4 or 5 grams. Okay, so an individual can actually develop acute renal failure from consuming 4 to 5 grams of this in one go, right? Now, there have been cases of individuals, like I said, eating too much rhubarb, or particularly women in Britain who were having sorrel soup. So wood sorrel is, I think it's a type of tree or plant, and the leaves of that you can make into a soup. Now, there was several cases of individuals who consumed too much of this and actually died like there and then within a couple of hours. So it is a very real thing. This was once acknowledged, but not so much these days. Now, so I think it's not exact, but if I remember correctly, the acute toxic dose is between 4 and 5 grams. Now, let's put it this way. On a high oxalate diet, particularly, say, a vegan diet or ketogenic diet, which includes, like the things you said, you're having your buckwheat in the morning sprouted with almond milk with, all of these other kinds of high oxalate foods, you can easily top 1.2 grams per day, easily. If you're having a smoothie, you can easily get that. Now, there have been cases, there is some degree of individual variability here, and this is what we need to factor in, is that whilst the established toxicity dose is 4 to 5 grams or whatever it is, maybe a little bit higher than that, there are people who have experienced very similar symptoms by consuming a lot less. Okay, so these kind of established, elevated levels of toxicity, they're not exact. People are different. Our biochemistry is all different, and so some people are extremely sensitive to much lower doses. There was a recent case study published in one of the journals. I've forgotten which journal it is. It was about an individual who had, I think it was a couple of green smoothies per day or juices, and they were admitted to the emergency room with acute renal failure. So they gave themselves kidney failure, and they were in the ICU for a good couple of weeks after that because they would have died. So there are people who are juicing or having these juices and actually causing real, like they are overloading themselves to the point where they could kill themselves. So this is a very real thing, and this is completely within the dietary modalities that are commonly promoted as health promoting today, right? So, you kind of take this idea of juicing and you take it to the next level. So you do 4 or 5 juices a day. You could easily be getting 4 grams. You could get enough to kill yourself in one day. Now, I've had people get in contact. You see, I work with people from all around the world, right? Particularly people seek me out for certain things. One of those is to help them with potentially oxalate problems, but it's also to help with some of the B vitamins and things that might be related to that. And now I've had so many individuals who have come to me. I mean, I had this one individual who said that she had a green smoothie, and I think it probably, from what she said, it must have been around 800 to 900 milligrams. Generally, the majority of people, they can do this for a long period of time and only start to accumulate these toxins and see symptoms over a long period of time. But actually, some people have an immediate response, and they may not have acute kidney failure, but they can have symptoms which are completely debilitating. So this one individual, she had the green smoothie and she thought she was having some kind of an allergic reaction. What I suspect was that it was actually acute oxalate poisoning. She developed all kind of neurological injury, brain fog. She was hospitalized, not with kidney failure, but actually with a kind of strange neurological condition. Her naturopathic doctors did not believe it was due to the smoothie, but after looking at my videos, looking at the work of Sally Norton, Susan Owens, she actually came to the conclusion, and I agreed with her, that she caused herself an acute oxalate poisoning episode, and she's going to have to deal with that probably for the rest of her life. Okay, it is that severe. At least she's going to be working on this stuff for the next 5 or 10 years. And so this is really key, important information. People need to understand that just because something grows out in the world, just because you find it in the supermarket, it can cause lots of harm. It can cause severe harm. Plants are fundamentally toxic in many ways. Many of the beneficial responses that we get from them, I think, apply to a healthy individual, many of these hormetic responses, like I'm sure Paul Saladino spoke to you about extensively, is that when the body is already under a lot of stress, when gut issues are present, when there may be a complicated health history, having a high oxalate diet is like throwing pouring oil onto a fire. Right, it's really that bad. So it's a dangerous thing that we're playing with, that we're talking about, Uncas.
Yeah, and at the same time, like, that might prevent sick people from getting better. And I just found a photo the other day. Like, I've been like 2000. What was it, 17, 18? No, I think January 18. I've been working the Olympic Games in Korea. And I have two pictures from one day, and then the next day. And as I said, like with the winter squash, I look like like a frog or something like this, Like the difference couldn't be more. And the only thing I did, I indulged in nuts. I bought like 4 kilos of different nuts they had there in the supermarket, and a couple of like I forgot the name, like a nut it's hard to get here, and which is touted to be the most superfood, whatever. So I just like had a lot, I mean, I gotta say that about myself. I overdo everything, So having a few almonds, like a small handful or something, would probably not cause any issues with me. But I don't eat like 10 nuts, I eat like 200. At least. So, and then I would get sicker, and then I would like, now I'm getting sicker. I got to do more green smoothies. I got to eat more nuts, step even more away from the bad stuff, and put more turmeric and drink more green tea, and go out and indulge on the blackberries and the blueberries and everything, and buy the expensive blueberries and everything. So this is like, it just leads you. Desperate people try to mitigate their symptoms, and they might just look into the wrong direction and just make things worse and worse and worse, and actually getting into a very dangerous zone.
Yeah, I couldn't have said it better myself. I think that is exactly what happens, and really, I'm sure you probably know, like you said yourself, and I find this working with people who have the initiative and the motivation to actually kind of go against conventional recommendations in terms of medicine, look at nutritional information, look at alternative health, and try to improve their own health conditions. What I see is kind of a similar kind of personality type. I think many of us are like it. People who are interested in health, who are interested in improving their health, they jump in head first into everything. And it's like, oftentimes you see people don't just put in 100%, they put in 500%, and they do everything right, like excessively almost. And so with this kind of individual who is consuming these oxalate foods in very high amounts because they think it's healthy, like you said in your situation, it without a doubt does make them worse. So this is a very common story that you hear going through someone's history, because that's what I do when I work with people. I like to go through all of their history and find out what led to what exactly when. And oftentimes what you see is that when they started doing the green juices, when they started consuming many of these superfoods, things got worse very quickly. Things go downhill almost immediately. And it may not be an immediate reaction in the body, but things generally tend to go downhill. They may get some more diagnosis. Their gut issues may gradually get worse. They may get more joint pain, more brain fog. Their autoimmunity might get worse. And it gets worse and worse and worse until they reach rock bottom. And in some people, that's being bedbound. Right, being bedbound before they can break free of the dogma of these kind of superfoods, vegan ideology, whatever it is, and actually start. And that's when they find either my work or Susan's work or Sally's work, and things click. They click because there are so many people who are in the same position who resonate with exactly what you just said.
Mm-hmm. Mary can touch on celery juice a little bit. So celery is, from my understanding, also quite high in oxalates, and this is pushed by somebody called Anthony William, the medical medium, so bestseller author of many, many books, and he's pushing this thing. I mean, he's pushing a lot of things, but one of his big things is the celery juice, so you have to drink that as much as you can all day long. So this is basically, in my understanding, an oxalate drink. What do you think about that?
It is it is without doubt an oxalate drink. You have to think, if you're eating celery now, while celery isn't one of the extremely high foods, I mean, it still contains some oxalate, right? And you think, if you eat celery, if you eat any whole food really, is that you're getting a lot of the water and the fiber. So you can only eat so many sticks of celery, you know, before your stomach gets bloated and you feel like you don't want any more. So your innate kind of the way that your body works is so that you don't overeat things like that, like things like fruit, things high in water content. You can't overeat it. Now, that's not to say that it might not cause you a problem if you eat a bunch of it, but generally by eating something as a whole, it's you know, you've kind of got a bit of a defense against it with your appetite. Problem is, when you juice something, even if it's not extremely high, now celery, it is relatively high. It's not one of the highest, but it contains oxalates. When you juice it, what you are doing is you are fundamentally bypassing your own defense mechanisms to prevent you from eating too much of it, right?
Yeah.
You're getting all of the oxalate out of it, you're concentrating it, and you're making it into a juice. So you could, I mean, theoretically, you could juice 2 heads of celery and put it in a pint glass, right?
Sure. I mean, you could probably eat like 2 sticks or maybe 3 or something like that, realistically. But for like 1 glass, I've just looked up a video prior to our conversation from Anthony Williams. So what he recommends, like the amount he wants, like people to have like half a liter, you know. So that's like 1 portion, like 16 ounces, I think. And so you take the entire, I don't know how you call it, you know, the entire thing, you know, like all the sticks and juice that, you know. So nobody could ever eat that, you know. And if you want to do it even better, you would do a second one and drink it all day long.
Yeah, so right. So that is going to be very heavy in oxalate, right? So now this is where it gets confusing. I mean, I will agree that I fundamentally disagree with Anthony Williams. Is that his name? The medical medium guy? Yeah. I fundamentally, I disagree with that notion. I think it's dangerous personally. That's because I've had several people who've tried to do his juice celery thing. It made him a lot worse. However, it's confusing because there are some individuals who claim that it helps them. Oh yeah. So there's a guy called Dave Mayo. He runs a website called Hack Your Gut. So he kind of thinks very much outside the box of things. And so he was trying to make sense as to why this might happen. Now, there are certain compounds in celery juice which may help the gut lining kind of regenerate or may help a leaky gut. Okay, so I don't discount that there may be some kind of chemical which is providing some benefit in some people, but there's loads of other ways that you can do that without potentially risking the vast amount of oxalates. I mean, I don't think that I don't agree with the idea of juicing like standard. I don't think anyone should juice anything because you don't find that stuff in nature, and that you can easily overconsume something. Like in terms of plant toxins, you can overconsume it by juicing it. Whereas if you were to eat it, as you said, you could only eat 3 or 4 sticks at a maximum. I mean, celery is horrible, you know. Who would want to eat 4 sticks of celery? You need bunch of hummus or like liver pate or something just to get it down, right? It's repulsive. So realistically, like if you're going to be juicing anything, I think that is problematic anyway. That's not to say that there might not be some small mechanism by which it helps some people, but I have heard some horror stories with it. And there's a bunch of people who say that it helped temporarily, but then actually they got a lot worse. So I would say
also the inclusion of things, you know, like you said that in the beginning, like healthy user bias, you know, people starting on that thing, they having the celery juice, but they're going to be out more in the sun. They're going to exercise more. They're having a walk, you know, they just take care of themselves. You know, that's why they actually do it. You know, so that might be confounding factors, but then on that kind of low nutrient dense, I'm sure like Anthony William will not agree. Low nutrient dense diet, you know, long term, people will get into trouble, I think. Anthony Williams, I just looked it up. You know what he actually says about the oxalates, and I just want to quote him. He says in his own website, okay, medical research and science has not discovered that there are antioxalates in fruits, vegetables, and leafy greens that prevent the oxalates from causing us damage the current trend tells us they do.
I mean, right, this guy gets his information from like channeling angels, right?
Yeah.
Was he channel angels or something? Right, okay. So I'm not here to dispute that or whether that's true or not. What I do know is that research does know that there are antioxalate factors, and that is minerals. That's calcium, right? So calcium is an antioxalate factor to stop you from absorbing it. That's not to say that it's not going to cause you problems. I mean, until he's got some like fairly thorough research to back up his claims, then I mean, I'm going to pass that off as complete BS personally, because I've worked with hundreds of people who've been severely damaged by this stuff. So, I mean, you know,
I think he's just trying to protect himself, you know.
I think he is.
He probably didn't know. I mean, if he's actually, I'm sorry, I mean, this is just pure speculation, but if he's actually getting his information from the spirit, as he claims, or he has like a huge team, because he's actually kind of writing books, and there's a lot of good stuff in it, I heard. But it helps people, you know. So there must be like, he must have a team that actually gives him a lot of information. And they came up with this celery thing, you know. I mean, you always have to have something unique, you know, don't you?
Yeah.
And but they didn't know about that. And now the critics come up and say like, oh yeah, actually there's something that only I know, you know, of. You know, so that's protective argument. Nobody can say something against it because we don't know. We don't have a communication to spirit.
Yeah, it's damage control, isn't it? You know, it's I would agree with that. I mean, again, like if he can back up his claim, then by all means, you know, I try not to be dogmatic about this stuff, and I try to look at it. But if there were antioxalate factors in certain vegetables aside from the minerals, then why do so many people get sick from eating too many of them, right? And I've had, as I said, you know, I've had several people who went through his protocol, actually got a lot worse before they knew about oxalates. So I'm calling BS on that one.
Okay. So can we talk about, I asked you before, I'm not sure if you have really answered that, like can we detox it in the liver and then kind of transition into oxalate dumping?
Right, okay. So are you talking about specifically the stuff that is produced by the body, or are you talking about what's coming in through the diet?
What's coming through the diet? I mean, the body can, I mean, we have heavy metals, we have so many toxins, and we have a ton of detox capacities, you know. I mean, they're clearly overloaded these days, but our body can deal with foreign things. How is that with oxalates?
Right, okay. So if you look at something like metal, for instance, arsenic is going to be dealt with through, right, to keep it simple, the liver has several different what we call pathways. Now you have phase 1 pathways, and then you have phase 2 pathways. We'll talk specifically about phase 2 pathways. So in the liver, you have various chemicals that your body can produce, or amino acids that you can derive from the diet, which what you do, you conjugate them with a toxin, or you bind them with a toxin. When you bind them with a toxin, you carry it out through the bile, and it goes either throughout the kidneys or through the gut. That's how you detoxify things. So these pathways called conjugation pathways, where you're binding things and carrying them out. That is detoxification. That is the definition of detoxification. You're using sulfur, you're using glutathione, you're using methylation, you're using acetylation, glucuronidation, all of these different pathways, glycination, okay? There's a bunch. None of those apply to oxalate, okay? You do not have an innate capacity to detoxify oxalate. You do not conjugate it to make it a safe compound. You see, when you have a metal, or when you have some kind of a chemical which you are getting rid of, you activate it, so you make it a little bit more dangerous, but then you conjugate it. Once it's conjugated, it's safe. It's not going to cause problems. You just get rid of it. When it's bound to a glutathione, for instance, or it's bound to sulfate, it's no longer a problem. As long as you can get it out, that's fine. That doesn't occur with oxalate. You do not bind anything with oxalate. No, oxalate remains in its whole form. It remains as a oxalate salt. So whether that's potassium oxalate,
because it's already bound. You know, you said you have the oxalic acid, so it binds to calcium or other minerals, and then we have a compound that can't be broken into anything else, right?
Basically, yeah, that's exactly what it is. So you can have the oxalic acid portion move from different mineral ions, right? So if it's with potassium, it can go to magnesium, and then it can go to calcium, but it can't. You're not conjugating it with any inherent detoxification molecule that you would usually do with some kind of toxin or chemical. And so what this means is that as it's on its way out of the body, now your body will try and get rid of it. And it does this primarily through various routes, primarily either through the kidneys or through the gut. Okay. So it can do this via several different mechanisms, but on its way out, it is not protected. Let's say it can cause damage on its way out. It can cause damage to the vascular system. It causes damage to the kidneys, damage to the urinary tract, damage to the gut, damage to the anus, for God's sake. I mean, if you look at, right, let's talk about this, right? You're getting rid of oxalate. Say if you've got a bunch of oxalate in the gut, the oxalate is so kind of corrosive or so kind of irritant to the soft tissues of the anus, it can cause things like anal bleeding, anal itching, anal, kind of like what they call, like, not fistulas, but sorry, I've forgotten the term, but essentially you can get ulcerations throughout the lower colon and actually throughout the anus because it's causing damage. Likewise, as I said before, you can get burning in the urinary tract. You can get blood, microscopic blood, proteinuria. You can get damage to the bladder, damage to the kidneys, damage to the vascular system, damage to the nerves. As long as it's moving around the body, if it's coming into contact with tissues, it can cause damage to them. So if you've got that consistently, a short period of time of that is not necessarily a problem because you can just repair. But when you've got that on a consistent basis, every single day, all day, because what you're doing is you're consuming a bunch of oxalate foods, then that is going to cause problems long term. That makes sense?
Yeah, that makes a lot of sense. So how do we get? Let's assume, like, let's just take me. I've been over consuming oxalates for a couple of years. I don't think they're doing too much harm to me, but also at the same time, I don't know. But now I kind of stop consuming them. What's going to happen?
Right. Okay. So it's important just to flesh out the kind of process, what happens when you eat a high oxalate food. We spoke about how it's absorbed through the intestine. You can have absorption throughout kind of many of the kind of soft tissues in the stomach. A lot of it's absorbed in the stomach. Essentially, right, if you think of your blood as kind of a reservoir, there's a reservoir for minerals, but it's also a reservoir for oxalate, right? So what's happening is when you have oxalate absorption, and it can also be absorbed by the lungs, by the way, but that's a whole other story. When you get oxalate absorption, what it is doing is it's absorbed into the blood in a soluble form. So that's, say, potassium oxalate, let's say. What that is doing is it's propping up the blood oxalate level. So you think of your blood having various levels of different nutrients, and that's what you will do if you go for a standard blood test. Standard blood panel will measure the types of white blood cells. It will measure, if you get the electrolytes, it will measure potassium, calcium, sodium, chloride, okay? Well, likewise, oxalate is an ion, it's a charged particle. So essentially what's happening is you have a level of oxalate, and that can fluctuate. That can go up, that can go down. And that correlates with what you have eaten. So if you eat a high oxalate meal, then within a couple of hours, your oxalate level in the blood will pump right up, okay?
How can we measure oxalates?
It's very difficult to measure. It's very difficult to measure because we'll talk about this in a minute because we have to speak about dumping and the processes that occur there. Mm-hmm. A lot of what we know, again, is from the genetic research on primary hyperoxaluria. But essentially, what's happening is when your blood level of oxalate is pumped up, you're going to get it traveling around the body. Again, it may be precipitating as calcium oxalate in certain tissues. It particularly, it is actually mostly it's often precipitated in places where there is past injury or where there is current injury. So because if you have an inflammatory process, say in a joint, you're going to get elevated blood flow to that area. Or for instance, if you have inflammatory process in any other part of the body, you get increased rate of blood flow through that area. And therefore, if your blood is high in oxalate and your blood is also high in calcium, you can actually get precipitation of calcium oxalate in that tissue. But right, let's say this goes on for a long time. You store a bunch of oxalate. You get rid of what you can through the kidneys. Right, here comes down to your question. So you say if someone's been consuming it for a long time, what happens? Well, if you, like yourself, has stopped consuming it, you've lowered your oxalate intake, right?
Yep, from the occasional moments where I eat some chocolate. Yeah.
Right. Okay. Well, if you're gonna pick out on oxalates, it has to be on chocolate, right? I can understand that one. Trust me.
Do you eat chocolate?
I do on occasion, very occasion. I don't think that I particularly have an issue so much with oxalates. Not to say that it's if I was eating a bunch, then it wouldn't be a problem. But yeah, I do on occasion, not very often though. Right. So
Okay.
back to the question. Right. So you said if someone eats a high oxalate diet, they accumulate a lot in their body, and then they reduce that. Right. So what happens when you reduce oxalate in the diet? What happens is your blood level of oxalate goes down because it's not coming in through the gut, right? So when you have less coming in from the gut, the drop of oxalate in the tissue, and this hasn't been very well characterized, the mechanism, but it definitely does occur, is the drop in the blood level of oxalate is going to signal. You see, tissues have sensing mechanisms. They sense the various, I think it's maybe through electromagnetic frequencies or whatever is going on, maybe through light, maybe through some other kind of mechanism. What's happening is they are sensing the degree or the level of minerals, the level of ions, the level of nutrients in the blood. So there is an oxalate sensing mechanism to tell you, okay, when the tissues see that there is low oxalate in the blood, remember that oxalate is a toxin. Oxalate can activate the immune system. Oxalate can, when it's in too high amounts, it can cause acute kidney failure. So your cells need to know, or your tissues need to know how much there is in the blood at any one given time. And the reason is when your blood level drops, then your tissues basically say, now we can get rid of this stressor. Now we can get rid of this toxin. So when the level drops, your tissues start to release oxalate into the blood at a manageable level. Okay. As you go from a period of having lots coming in through the gut, that decreases. When it's coming in through the gut, your tissues can't release oxalate at the rate that they would like to, because then you would overload oxalate in the blood. You could potentially cause kidney failure, deplete your minerals, everything like that. But when it stops coming in from the gut, your tissues start releasing it. Okay? Your tissues release it, and that is when you get an exacerbation of previous symptoms. So let me explain, right? The tissues follow some kind of a circadian rhythm, and it's different for each person, but it follows some kind of rhythm. And what we refer to this as is dumping. Now, dumping is not detoxification like we spoke about before. Dumping is essentially when your tissues dump what is oxalate, so dump the whole molecule of oxalate into the blood to prop back up the blood level when the blood level has gone down. This is the rationale for having a low oxalate diet. When someone goes on a low oxalate diet, because the low blood level, their tissues start to release it, and this is the way that we get rid of it from the body. This can take a very long time, and the reason for this is you think about it, if you were to dump all of the oxalate into the blood, you would probably die immediately. Okay, because if you've got a lot stored up, then you would overburden the kidneys, you would overburden the entire system. So what happens is you start dumping a bunch into the bloodstream, and this goes either out through the kidneys or the gut. It can also come out through various other areas. It can come out in the skin. So one of the things that you find, the body is a very, intelligent organism. It will employ any method that it can to get rid of stuff. And so the skin is a key detoxification organ, and so we use it to get rid of junk, essentially. And this is why sweating is so good. But essentially, it can be coming out the skin, and what you might see in this case is that you might see actual crystals or what look like little shards of glass coming out of the skin. It often causes rashes, but if you get like a microscope or something, you can see the crystals. I have many people who have this. Oftentimes it comes out of their jawline. That's very common. But then you also have it can come out of the mouth, can come out of all of the soft tissues. So you can actually have oxalate crystals kind of coming out of the gums and whatnot, and it can cause things like gum bleeding, gum irritation, gum inflammation. You can have it coming out of the eyes. So I get a lot of people who tell me that actually they have oxalate crystals which literally come out of the corner of their eye. Okay, and that kind of really scares them because they don't know what it is, and it looks like a are you still there? You still there?
Elliot?
Did you lose
yeah.
me?
I lost you. Yeah, you just said there's oxalates coming out of the eyes.
It can come out of the eyes, and that really scares people. It can come out of the eyes, and it looks like crystals of sharp glass, and it actually hurts their eyes, and they can get kind of like gummy eyes and kind of like red and swelling and pus coming out of their eyes. And actually, there's usually crystals as well. It comes out of the gut, so there is a mechanism by which we are dumping it into the gut, and then it's coming out via the feces, and then it's also coming out of the urinary tract. Now, for whatever reason, this follows cycles. Okay, so there are some individuals who have it once every 3 weeks. Some people have it maybe once every month or every 2 months. Some people have it a lot more frequently. And for some people, it comes at certain times of day. So, for instance, it might come in the evening time, or it might come in the afternoon time. And for whatever reason, it tends to follow different cycles based on individual variability. And what you would see then is you would see the joint pain. Like, for instance, if someone's on a high oxalate diet and they have frequent UTIs, they have joint pain, they have kind of muscle pain, they have fatigue, they have all of these issues, when they go on a low oxalate diet, they'll probably feel much better for a very short period of time. It can be a week, it can be a month, it can be 2 months. They can have something called a honeymoon period. But then what happens is they start to cycle and go through this dumping process, and all of their symptoms, which got better when they removed oxalate, actually get worse temporarily, and they think that they're relapsing, but they're not relapsing. This is the natural progression of what must happen. And so they think they've done something wrong, but actually it's important to coach them and educate them that this is the body's way to get rid of what they need to get rid of. Okay? So, as I said, all of these different kinds of exacerbations of symptoms can be diarrhea, can be constipation, can be kind of often burning urination. You will see cloudy urine. So actually crystals in the urine, microcrystals in the urine. You can see kind of blood in the urine sometimes. You can see headaches, acute dehydration. So what's happening is that when it's going into the blood, it's then binding with a bunch of minerals. Okay, so it's binding with your own potassium, with your own calcium, with your own kind of magnesium. So what this means is it's carrying them out through the urine or the feces, and therefore you are at a much higher requirement for certain minerals. You can end up with kind of tachycardia or weird cardiac type symptoms because you are acutely hypokalemic. Oftentimes you see potassium, so actually acute hypokalemia, very low potassium levels in the blood, which seems to be related to actually this dumping of oxalate into the blood, and it's binding with a lot of it and carrying it out. So it makes you acutely deficient during these times. Okay.
All right. So how long might that dumping process take approximately?
Well, I mean, this is I have not been in the field long enough to be able to determine when someone goes from being completely like oxalate overburden to having it completely disappear. People generally tend to improve within 6 months to a year. Some people might improve a lot sooner on. Other people maybe not. Now, there are certain individuals who say that actually it can take from anywhere to 5 to 10 years to actually get rid of this stuff from the body. So this is something which is very long term, and this is kind of denotes the difference between ordinary plant toxins and oxalates. They're two different animals, right? And it's like the body will accumulate it, and it takes a long time to get rid of it. And all that you can do is remain on a lower oxalate diet and try to do some of the strategies, which I think we'll talk about. Use some of the strategies to try to mitigate the symptoms. But the chances are dumping will be very severe in the initial stages, and it will gradually improve as the body starts to get rid of this. Now, there is something very important to note, is that I generally don't recommend most people, if they have been on a high oxalate diet, to reduce oxalate very quickly. That is a very dangerous thing to do, potentially, because what you end up with, and I've had several individuals, much like the other practitioners in this field I've seen, is people can end up, as I said, with low potassium, with kind of, it's called a metabolic crisis, so to speak. you can actually end up with people being admitted into A&E or the emergency room because they think they're going to drop down dead, because they think they're having a heart attack or some kind of thing, or they collapse. Because when you reduce oxalate really quickly, it triggers the body to get rid of this stuff, but it can be overwhelming for the system. It can really overwhelm someone's system. It activates the immune system, so it can activate the lymph glands and cause like a kind of fever, cause symptoms which are very similar to what you would get if you were suffering from some kind of an acute infection. Can put you in bed for a couple of days, and in some people it might put them in hospital if they go too fast. So it's very important not to rapidly get rid of it. That said, some people do that and they're fine. So again, it's highly individual. There's this whole carnivore movement. Excellent. Some people respond really well. Some people get worse on that diet. And I think a lot of the times when they're getting worse, while sometimes it may not be that they can actually suit to the diet for whatever reason, oftentimes what I personally see is that actually they've gone too quickly and they end up dumping a bunch of oxalates.
Okay, so better go slowly on that. You wanted to touch on, like, can we actually measure that, the oxalates in our body?
Right. Okay. So there are a couple of medical tests that might be used if someone is suspected to have kidney or oxalate stones. One of those is going to be 24-hour urinary oxalate. So that is something, and I do have some clients who have come to me based purely on the fact that their doctor has randomly run a 24-hour oxalate and it's come back really high. Okay, that's something that you might see sometimes. There's also a test called the Great Plains Organic Acids test. Probably my favorite test on the market, not necessarily for oxalates, but for other nutrient deficiencies and things. But essentially, they do have 3 markers on there for oxalate, specifically for oxalates. One of those is measuring just pure oxalic acid in the urine. Another one is, there's 2 other markers which are related to whether the liver's making oxalate or not. But essentially, oftentimes, if you understand this process or this cyclical process of dumping, potentially there's a circadian variation on that and it differs between person to person. It's very difficult to say whether you're going to do that test and it's going to be at the right time that you're dumping oxalate in the urine, because it's not a consistent process. It's not something that occurs kind of the same amount every single day. It's not been established like a blood test. It's something which is kind of sporadic and cyclical. So sometimes you may go for a urine test, it may come back normal, but actually you've already dumped oxalates that day. You're going to do it over the next week or something. And so oftentimes people are misdiagnosed. They're told that they don't have oxalate problems when they clearly do. And I find that actually the best kind of way to look at it, or the best way to proceed with that, I don't use tests as diagnostics. I go through history, I go through symptoms, I go through kind of comprehensive case assessment, and I make a decision based on a hypothesis. And if they respond well, they respond better to a low oxalate diet, then it's clear that actually oxalates are likely going to be involved here. So I tend not to use tests as diagnostic markers because they are inherently flawed.
Okay, got it. All right. I heard that there's certain compounds like vitamin C or glycine that actually could convert into oxalates. Is that true?
Right. So this is something which is kind of debated. I'm not really sure where I stand on it, I'll be honest. Right. So there is some animal literature which shows that in mice or rats who are B6 deficient or B1 deficient, what you can get is feeding the amino acids hydroxyproline and glycine can actually produce the oxalate precursor in the liver called glyoxal, which is theoretically going to be converted into oxalate. That being said, I don't know how much this is really applicable in real life. I think if someone was taking a bunch of glycine and they were very much B6 deficient, I guess it's theoretically possible that they may actually end up with endogenous oxalate production. Now, there are some people who have these issues and they can't tolerate stuff like bone broth, or they can't tolerate glycine supplements. That being said, I'm not sure how much clinical relevance it really has, because I tend to get a lot of my people on collagen. I get them eating lots of muscle meat, and muscle meat is actually very high in glycine. Like, there's this idea that you need to eat collagen to get glycine, but I mean, it's bogus. There is so much glycine in muscle meat, you'd be amazed. So these people tend to respond very. Sorry?
Isn't there much more methionine, and you gotta balance that with organs and bone broths and stuff like that?
Yeah, I mean, indeed, there's the ratio of, you have methionine, cysteine, and glycine ratio, and you could say that you're getting more methionine to glycine in a ratio, but if you actually look at the amount of glycine in muscle meat, there is still a lot. Like, in comparison to methionine, when you're looking at the ratio, no, that's a different argument. But I mean, just simply from, just from kind of baseline, eating meat provides a bunch of glycine anyway. So any kind of meat that you eat, because collagen is essentially the most abundant protein in the whole entire body, and it makes up a lot of muscles. So actually, these people respond good to meat. So what I'm basically saying is that some glycine does not seem to be a problem for them. So I suspect it might be more related to the kind of glutamates and things that you might find in collagen powder, which are causing them an issue. But I don't know. I mean, it's theoretically possible. There is also this thing of vitamin C. Now, I will be honest, like, this is something which again is debated in the research literature. It seems to be clear in the animal research, but there's conflicting data. So there are some kind of individuals who will say you must not have any more than kind of 250 milligrams of vitamin C, because otherwise it will convert into oxalate. But then you also have some people, like, I mean, there's Doris Lowe, for instance, who is a major vitamin C proponent, especially talking about the effects of kind of 5G, the effects that we're going to be experiencing with 5G radiation, how we already have things like Wi-Fi, 4G, all of these things, how these at the cellular level are increasing our requirement for vitamin C due to the redox balance. Okay, so I will be honest, I am not against vitamin C. I think it's highly individual, and I'm not dogmatic about it. I try not to take a stance. I just try to present the literature. So for instance, if someone takes vitamin C, and I have several people, they take ascorbic acid and it makes them feel a lot worse, gives them joint pain, gives them any of this stuff, then I suspect that is converting to oxalate in their body. It's important to note that cadmium, if there's a lot of cadmium, this is going to be a key driver for catalyzing the oxidation of vitamin C into oxalate. One thing I didn't say is that if you look at the metabolic pathways, vitamin C can be auto-oxidized into oxalate fairly easily. One of the key drivers of that is cadmium. So I think if someone has like heavy metal toxicity, they have oxalate issues, and they try ascorbic acid, makes them feel worse, that's a problem. If it gives them kind of UTI symptoms, you see that in some people. Other people, I will be honest, I consult with many carnivores, right, who have full-blown scurvy. Right, and this is something that many people say, oh, you never see carnivores with scurvy. But actually, I mean, just this week, I've had 3 carnivores, okay? One who had terrible bleeding gums. The other one who had, like, chronic diarrhea. I gave them mega doses vitamin C. So in terms of, well, I say mega doses, 3 or 4 grams per day. His gums completely stopped bleeding, and his digestion improved. And the other one, her diarrhea, I mean, she'd been through, I don't want to name names, but she'd been through all the big kind of, the big clinic in carnivore, the International Clinic of Carnivore, the clinic that uses carnivore diets. She was told there was nothing that you could do to fix her diarrhea. She'd spent thousands on GI specialists. She came to me. I put her on 4 grams of vitamin C, and it cleared up in 3 days. And it's been that way for 2 months now. Okay. So I think there's always nuance, right? And it's important not to kind of, like, people come to me and they say, oh, I shouldn't take vitamin C because I have an oxalate problem. And I say, well, actually, we need to look at you individually. You are an individual. You are not a test subject. You are not a clinical biochemistry textbook. We need to actually find out what you personally tolerate and what you need, because it differs between each individual, Okay.
Scurvy, you need only 10 milligrams of vitamin C to prevent scurvy.
Sorry, say that again. I lost you there.
Yeah, sorry. The connection was gone. There's a study that says that you only need like 10 milligrams of vitamin C actually to prevent scurvy. And there's not a lot of vitamin C in muscle tissues from animals, but there is in the organs, especially in the liver. So you could kind of get along, but probably doesn't hurt to take a little bit more.
Well, like I don't want to detract away too much from this conversation, but this is a fascinating topic, really is. And I would say it seems that the majority of people on the carnivore diet really do fine without taking any vitamin C. They do fine eating some animal organs. This particular individual, I mean, he was eating probably more liver than anyone
Oh,
else that
really?
I would recommend. He was eating spleen, the eating what is it, like sweetbreads, all of this kind of stuff, which is said to have lots of vitamin C. But for whatever reason, it seems that his requirement was just higher. So
Yeah.
it was only when we supplemented vitamin C that things improved. Now, I'm not saying that actually there's other things going on which are increasing the requirement, which I suspect to be the case.
Yeah.
What I am saying is that it seems that from a more kind of functional approach, functional medicine approach, I try not to paint everyone with the same brush and apply the same things to everyone. And so whilst I agree that the carnivore diet is likely beneficial and likely kind of sufficient in terms of vitamin C requirements for the majority of people, there are always outliers, and this is what kind of makes things confusing.
Yeah. Individuality is just a strong thing, and
Yeah,
we
yeah.
just gotta listen to our bodies. Like we have this kind of mental dissociation. We believe in certain things, like we believe in a certain type of diet, whatever it is, like the paleo diet or the vegan diet or whatever, and then we just stick to that. Or even like the high oxalate foods. We believe in these because they're so healthy. We have seen studies or just blog posts or whatever that are copied from one to another, and we believe into these things, and we're getting worse, and we just take more of it. So we have already talked for quite a bit. What would be interesting for me is like, we all these foods that we mentioned, Oh, by the way, I just wanted to touch on one little thing because it just popped up here on my screen in a way. You mentioned sorrel, which is in German Sauerampfer, and I just looked it up for some reason, and it shows like a huge list. There's something that's very similar to it, and it's a clover. Yeah.
Okay.
So it's a wild clover, and there's a huge list here on Wikipedia from this, and they're all called, like the Latin names are Oxalis something, Oxalis articulata, like joints, Oxalis bowayi, like bowel or something like this, Oxalis compressa, Oxalis whatever, this huge list, so this is known, and there's kind of a base to it. So is there something, all these lovely foods like almonds and quinoa and buckwheat and sweet potatoes and turmeric and cacao and cinnamon, come on, is there anything we can do to mitigate, to keep eating these and mitigate the damage that they do to our bodies?
Right. Okay. So good question, I guess, because there's lots of ways that you can approach this. What I will say, I want to preface it with, if someone has an oxalate problem, if they have long-term accumulation, the best possible thing and probably the only possible way that they can effectively reverse the health condition is by gradually moving towards a low oxalate diet, to gradually reduce the oxalate content in the diet, because no matter what you do, you can somewhat mitigate the oxalates coming in. You can do various kind of supplements, things like that, but ultimately you need to reduce the amount, because that is where most of the oxalate is going to be coming from. It's the diet. So you need to find replacements. You need to reduce your intake. Really the best thing, the way that I try to get this through to the people that I work with is that you need to stop seeing food as entertainment. Food is not entertainment. Food is fuel, right? If you're so hung up over the flavor, the texture, and whilst I know this can provide people pleasure, if this is the only thing that they eat food for, they need to really have a hard kind of sit down with themselves and be honest with themselves and say, right, okay, I need to choose. Do I prefer having temporary sensory pleasure on my taste buds, or do I want to get better? Because the two are mutually exclusive. The two, if that's the right word, sorry, I don't know if I said that in the right context. You have to choose one or the other. Okay, you cannot have both if this is your problem. And whilst you can find very kind of tasty alternatives, if you have a chocolate addiction and this is driving your fibromyalgia, you need to stop eating chocolate, period. There's nothing you can do about that. You need to stop it. Otherwise, you can stay sick, and that's up to you. But, then why are you even listening to this health podcast, right? Because you want to improve, you want to change things. That being said, what you can do is you can try to mitigate some of the effects of oxalate. So for the average individual, right? For the average individual just wanting to reduce their absorption, you need to be eating foods which are high in calcium with the oxalate containing food. So for instance, if you are not intolerant to dairy, I think a lot of people are, but if someone is relatively healthy, they're okay with things like yogurt, they're okay with, other types of dairy, then actually having that with the food is going to greatly reduce the amount of oxalate that you're going to be absorbing. Okay, that's one thing. Another thing that you could be doing, I don't see this as an effective long-term solution, but taking a source of calcium with the meal, before the meal. Calcium or magnesium would do, but ideally calcium. Calcium is the tightest bond and it's the most insoluble form of oxalate. So if you can take calcium being eggshells or being some kind of calcium supplement such as calcium citrate, a teaspoon and a half of that before a meal, that is going to help you to protect you against absorbing excess oxalate. The only problem is that calcium, when you take it in a very high amount, what calcium also has the tendency to do is affect the absorption of other nutrients such as fat. Okay, calcium forms a soap in the gut with fat, and that can actually prevent you from absorbing it. Which means that it can prevent you from absorbing the fat-soluble nutrients if it's taken in high enough doses. It can also influence the absorption of things like zinc and other nutrients which you really need. So actually, I don't think it's an effective long-term solution to be relying on a high dose of calcium before eating oxalate foods to justify your high oxalate diet, right?
Okay. That's something funny. I tried to educate my daughter. She's getting 11 in a few days about that, and she's such a clever girl. And so I said, like, hey, come on, because I was always eating like the dark chocolate, like 85% or maybe even more. So, and then we talked about all that, the oxalate issues, and she kind of takes a piss sometimes, because she says like, yeah, daddy, and in 2 weeks oxalates are going to be good, because she saw me going through so many stages, of dietary guidelines and everything. And I was preparing her before I was doing it for me, doing the almond milk and everything, and like in my Vitamix, like just because I won't accept like the bad one from the organic shop, right? So I take my organic almonds and blend them and soak them before and everything. So I have like this really, really living milk, right? So what she says is, then it's and I also explained that sugar is quite bad. It can lead to inflammation, everything, but if you burn it, it's actually not that bad. So if you consume some sugar and then you go on a long run or something like this, it's actually not that bad. And then she said like, oh, daddy, then actually having milk chocolate or something like this, like a lower, more sugary, less chocolate would actually be much better, right? At least if I would go on a run then.
It's true. It is true. If oxalates are the primary thing which are causing the problem and it's not dairy, milk chocolate is going to be a much better option, and it would be lower cacao. So like 30% milk chocolate would be way better than having 85% dark. Even better, white chocolate, right? White chocolate is the best. Now, I don't recommend that, and I can't even eat dairy, so I can't eat any of that stuff. But ultimately, yeah, paradoxically, you think, okay, this has got higher sugar content. This has got milk, which is potentially going to be, reactive for certain people.
Milk powder.
But ultimately, the people who have oxalate problems don't react to this stuff as much. And the milk powder is containing calcium, which is effectively going to prevent you from absorbing oxalates. So her logic is perfect. Logic is perfect.
Yeah,
Okay?
I also thought that it's like you're just so clever, incredible with 10
Indeed.
years, Yeah. Okay. So having milk chocolate or yeah, white chocolate. Okay. So you really don't recommend that, but I had a guest recently, and I just mentioned oxalates, and he said like, oh, but this is only applies to people that don't know that you got to take dolomite with it.
Right, I think this is right. This way of looking at it is really problematic. Okay, I fundamentally disagree with this way of looking at things because, right, there are certain. Okay, we talked about calcium. There are certain things which do effectively bind with oxalate. One of those is charcoal. I think charcoal does. I think I think some of the other things like dolomite or bentonite or zeolite, basically these are clays, right? These are clays. I mean, they're not food. This stuff isn't food. Now, some people, certain cultures would eat it like with a meal. I mean, there's been cases of cultures who have been preparing certain root vegetables which are really toxic, but then eating a certain type of clay with it to bind to the toxin to allow them to digest the veg. Then the question is, if you don't have to eat the toxic veg because you have access to loads of other foods, why do you want to potentially put yourself in a situation where you are going to be inhibiting the absorption of other nutrients? Because that's what bentonite does. That's what dolomite does. That's what these clays and these things do, is they're not specific for toxins, right? They can bind with other nutrients as well, right? So it's the case with charcoal. Now, I don't have any issue with using binders. I use them with a lot of my clients in specific circumstances. But the question I really ask, and I think people need to be honest with themselves about, is if they need to eat clay with food, then is the food that they're eating really food? Like, is that food? Like, if they need to eat clay with it, I mean, what makes them think that that's a healthy thing to do? I mean, why can't you just eat a food that doesn't need to be eaten with clay? Why don't you just eat some meat or something? Now, I know that sounds kind of, maybe it's a bit like clear cut, like strict. I mean, I don't really mess about with my clients. I'm honest. I say, you either do it or you don't do it. It's up to you. But, I'll tell you what works, and then we'll try meet in the middle. But I'm not going to pander to your, basically, if there's something that made you sick, you need to give it up. You need to stop doing it. And there's the old saying by Hippocrates, right? It's like, if you're not willing to give up what made you sick, then you're not going to get better. It's fairly simple. That being said, there are. If someone...
still, could it be like? I mean, as a general idea to do that, I completely agree with you. But maybe at some points we want to kind of biohack ourselves into like, oh, today I really want to have that dark chocolate, or I'm invited there, and they have this. Could I just get something out of my backpack and just mitigate a little bit the damage?
Right, yeah. So that is the caveat, because actually if you're in a situation where, it's a social situation, it's a family situation, or you're in a restaurant, you can't get away from it. You can't do anything. And it's like, well, okay, on occasion, it's probably not even going to be that problematic to eat it if it's just occasionally. But then if it's a thing like a business meeting or something, and you can't really decline the food and you have to do something about it, yeah, I mean, there's charcoal. There's calcium. I'm not sure about dolomite. I guess dolomite probably binds oxalate. There's also certain enzymes which I don't have any clinical kind of experience with them, but I know that there are certain enzymes which you can take which help to degrade oxalate. So you take the enzymes, and they're like the enzymes which are produced by certain gut bugs, which are capable of degrading oxalate in the gut. So you can take that with the food. I can send you a link to that afterwards, because I'm not sure exactly. I don't know the name of it. I don't use it.
I'd love to.
Right. Okay. And then there's also what was I going to say? There's the enzymes, charcoal, clay.
What about lemon and citrates?
Right. Okay. So this is working on a different mechanism, right? So essentially, okay. So what you can do if you've got an established oxalate problem, there's a couple of things that you can be doing. So one of those, you want to work on multiple fronts, okay? You want to be looking at the mineral balance, the minerals that are affected by oxalate. You want to be looking at things which have been clinically shown to potentially dissolve or dissociate oxalate from calcium, so helping to in a very simplified way of looking at it, dissolve oxalate crystals and then help you get rid of that through the kidneys, through the gut, etc. So to do this, we need to look at several things. One of those is how your body's getting rid of it. So say you're dumping oxalate into the gut. When it goes into the gut, what you are looking to do is keep it in the gut. When you keep it in the gut, it goes into the toilet. The problem is if you don't have enough calcium in the gut, or your bugs are not the optimal composition for oxalate degradation, then what happens is that when you dump it into the gut, you actually can reabsorb it, and you don't want to reabsorb it. So what you need to do is this is where something like calcium or calcium citrate can come in handy, because what you're doing is you're binding it. Much like if you take it before a meal, it's similar process. When you are dumping, so if you know that you dump every night, or you know that you dump at a certain time of day, you can take it kind of an hour beforehand to mitigate that when the oxalates get into the gut, you take the calcium, it binds them in there. Okay, it binds them in there. So that's one thing you can do. The citrate component is useful because citrate has been shown to, as I just said, it's been shown to kind of dissolve oxalate crystals and break them apart, help you get rid of them. So this is something which is recommended for things like kidney stones. Very useful in kidney stones. You can take various different minerals in terms of the ones which oxalate binds to. So calcium citrate, magnesium citrate, potassium citrate. You're going to be affecting mineral metabolism when your body is dumping this stuff, so you can replenish those. Okay, I usually recommend people to replenish those. Sally Norton's does a lot of work on this kind of stuff. At the same time, though, we need to be looking at if someone has established kidney stones, then there is actually a herb which has been shown to be very beneficial, and this is called Chanca piedra. Chanca piedra. Chanca piedra can prevent the kind of the growth of new stones, while citrate is going to help you to potentially clear that. Okay. Now, whilst we're looking at the effects of oxalates in cells, if someone has a chronic oxalate problem, then we need to look at what it's doing to the energy metabolism. Generally, I find as a kind of rule of thumb, there's 3 main B vitamins, and Susan Owens has done a lot of work into this. 3 main B vitamins which tend to be problematic or low in someone with established oxalate problems. That is vitamin B1, vitamin B6, and biotin. So we spoke about biotin being kind of you can produce a functional deficiency via excess oxalates, but B1 and B6 are also involved in endogenous production, and I suspect that high oxalate diet can actually deplete those through causing inflammation, through kind of upregulating energy metabolism, acting as a stressor, all of this kind of stuff. So I generally find that those B vitamins are key. I give most people those B vitamins. They usually find that it helps. Sometimes someone can think they've got an oxalate issue, which is actually mimicking a thiamine deficiency. So actually by thiamine replacement, they tend to lose their oxalate issues, let's say, or they tend to improve greatly when a low oxalate diet didn't help. Now, in terms of, we've spoken about the minerals, right? It's important to note that the way that one mechanisms of getting oxalate into and outside of out of cells, particularly into and out of the kidney cells, is something called the I think it's this a certain type of transporter. I've forgotten exactly which one it is, but basically it's transporting oxalate. For every oxalate that goes one direction, you get sulfate and bicarbonate going the other direction. Okay, so what that means is if you've got high oxalate coming into the cells all of the time, what it's doing is it's actually causing you to waste sulfate. Okay, now you know your listeners, if they listen to Stephanie Seneff, then I don't know if she spoke about sulfate on your podcast. Did she say anything about sulfate?
Yeah, she did.
Okay, so cholesterol sulfate, the sulfation pathway, all of this stuff is kind of screwed by glyphosate. Essentially, sulfate is so important for everything that really happens in our body, and the oxalate causes you to waste sulfate, so it can cause a functional sulfate deficiency. What this means is that your joints, your tissues may have less of a kind of detoxification capacity for one, but also your structural integrity in terms of your connective tissue, your vascular system, all of these different kinds of things are going to be negatively impacted. So what I like to do is I like to replenish sulfate by providing a bioavailable source transdermally in the form of Epsom salts. This is essential. Okay, Epsom salts can generally help people because they provide magnesium. They also provide sulfate, which can be absorbed transdermally, and that has been shown to increase plasma sulfate. So Epsom salts baths are essential. What I like to do is if someone is releasing, say they've got joint or muscle pain, and they are releasing a bunch of oxalate from those tissues, because of the inflammation and the immune dysfunction that is going to be causing, I find that one of the most effective solutions to use to reduce pain and actually improve nerve function and things is topical DMSO. Okay, dimethyl sulfoxide. Now, you had a previous guest on about that, so your audience should know about the benefits of this. Dimethyl sulfoxide is essential, or I find it to be very helpful. It almost relieves the oxalate-induced pain within a couple of minutes. That can be applied topically on the joints, on the muscles. I don't know about taking it internally. I've never tried anyone to do that, but I have recommended it topically, and I find that people generally benefit a lot. You mentioned lemon juice. Lemon juice can be used. I typically don't recommend it that much. I tend to recommend the citrate supplements, but lemon juice can be very effective because it provides citric acid, it provides citrate. Someone can drink a lot of lemon juice, and it's going to ideally or theoretically going to help to clear out any oxalates, or kind of it's going to help to kind of affect the structure of the oxalate crystals. Okay. Again, it's all very theoretical because there's not much clinical research on it. There is some research on citrate and kidney stones, some research on the B vitamins in kidney stones. Ultimately, we are very much shooting in the dark, and we are relying very much on anecdotes, testimonials, and mechanistic data in terms of mechanisms for what might work. There is a wide variety or there's a very large community, a Trying Low Oxalates Facebook group that is over 25,000 people now. And there are people who are sharing their results. So a lot of what we know is that there are, tens of thousands of anecdotes all saying the same thing, all providing, documenting benefit from using these kinds of therapies. So we know that they work. It's just, unfortunately, if someone was to ask for a bunch of references, I could give them some, but it's not something that can be justified per se on a kind of foundational level through looking at scientific literature, because they're not doing it on it. Does that answer the question?
Yeah, I did. I was just looking. I just remembered that we had some community questions. I think we have answered most of them, but I just want to pick out one or two and just kind of call it a day then. There's like Marcus says, like, okay, but we hybridized so many foods today. Probably could it be that the foods have been like more toxic, contain more oxalates before, and now they have actually a lot less?
That's a really good question. What you find is that generally with the hybridization, we hybridize them to make them more tasty. We hybridize them to make them look nice and more aesthetically pleasing, to have higher sugar content and generally less toxicity. But in terms of like the data that we have about oxalate content in the food, it's relatively recent data, a lot of it. So I don't think it's changed much. I'm not convinced that hybridization in any way. I mean, it may have done a couple of hundred years ago, like when we started hybridizing, I don't know, bananas or like carrots, for instance, or potatoes. I can't answer the question for certain, but I don't think that the oxalate content has changed from now, where we are now, to when they were last tested. I think it's probably similar.
Mm-hmm. Okay. So for some reason you have a little bit of a hum, but now it's gone away. Eckhart says like he just comments that he loves you and he has learned a lot from you from other podcasts. And Susan raises a good point. She says like, okay, there's lectins, there's phytic acid, there's oxalates, and other anti-nutrients. Like, what on earth can I still eat?
That's a question that I get a lot. I will be honest. I find that when we focus on the minutiae, on the minute details, everything looks hopeless, right? Everything looks hopeless. The vegan argument, for instance, against meat is based on mechanistic details. So, for instance, if you look at when you fry a steak, you produce things like heterocyclic amines. You produce carcinogenic chemicals, which in a Petri dish do cause cancer, right? They can do. But in real life, it doesn't quite work out like that. And I think it's the same for things like phytic acid. It's the same for things like lectins, and it's the same thing for things like oxalates. Please don't get me wrong. I am not saying that this is a problem for everyone. I don't think that everyone needs to completely get rid of oxalate at all. What I'm saying is that there are a certain subsection of people who do have this problem. And for these people, this is where it's really important. And so if they display the symptoms or display the kind of reactions that you get to foods which are high in oxalates, then actually they need to focus on this. And it might be a case for them that they don't necessarily need to remove some of the other plant toxins, for some reason, people, some people can tolerate certain amount of lectins without it causing them problems. And I hate to be kind of controversial in saying that, but ultimately, there's people who eat lectins for their whole entire life and live to 99, like and the grandparents. Now, you could say that we're living in a different environment now, but ultimately the human body has some degree of resiliency, right? And so we can deal with a lot of this stuff. I don't think it's black and white that you need to be carnivore. I do think if someone
whole Brazil lives out of beans and rice.
Exactly.
Every day, even in the higher social classes.
Yeah. So if it was that bad, then I really, the human race would be dead by now, right? So it's not as clear cut as that, and so it's important not to lose sight of the forest from the trees, right? If that's the right kind of phrasing.
Yeah.
Is rather than focusing on the tiny things, try to look at how it affects the human body in real life. Quite frankly, a lot of people don't seem to have that many issues with oxalates, and I'm not going to try and convince people that everyone should give up dark chocolate, because quite frankly, if you look at the research, the people who eat dark chocolate generally tend to have good outcomes, right? What I'm saying is that there are certain people, and I suspect it's people who are particularly fragile, let's say, particularly susceptible. They've got poor gut health, they've got chronic health conditions. They maybe came into this world with less of an ability to adapt to the stressors. There's also people who, for whatever reason, have this as an issue, and there's loads of predisposing factors. I've written about this and I've done other interviews and stuff. So if there's anything that I haven't spoken about, by all means, anyone can get in contact with me or look at my articles or whatever. But essentially, there are certain things which make some people more predisposed to this issue than others. I would say that listening to your body is the most important thing that anyone can do. If they can do testing, that's excellent. And if they can do experimentation, that's excellent. So for instance, if someone wants to go on a carnivore diet, really be honest with yourself. First of all, don't go try not to be dogmatic about it. And whilst it may make sense, certain diets may make sense from a theoretical perspective, listen to your body, because your body knows best. And there are certain people who just don't go well with certain diets for whatever reason. And so if you can try to identify what triggers you, what you can tolerate and what you feel best on, that's going to be best for you. And it may be that you can tolerate a little bit more oxalate in the diet. What I would say is that I don't think that high oxalate diets are going to be healthy for anyone. In terms of, I don't think anyone should be having green smoothies. I don't think anyone should be having 9 cups of spinach per day. I don't think anyone should be having 4 whole bars of 99% dark chocolate, because then you are just asking for problems. Does that kind of answer the question?
Yeah, it does. And then 2 girls, they're asking kind of the same question. Is there any positive effect maybe from oxalates in our body? Because this girl, she says, like Liga, she says there's nothing in nature that doesn't make sense.
You see, this is something I've been racking my brain about for the past year or so. Okay. Is there a beneficial, it's like, right, it's in the context of free radicals, right? Context of free radicals, they were originally thought to be the worst enemy for cells. So this idea that your cells make free radicals, and that actually by taking antioxidants, you are going to be able to fix everything, and you're going to be able to massively improve longevity and health outcomes. Well, it turned out to be the opposite of the case. Actually, taking excess antioxidants had the opposite effect on longevity, because now we know that a small amount of stressor, a small amount of free radicals are actually really beneficial for the cells, and that you don't want to quell that with antioxidants. So the way that we view the body is actually seeing things that were previously thought of as bad are actually now acknowledged in small doses. They are beneficial, right? And I do kind of think that this idea of hormesis, a low dose stressor, a low dose toxin, is going to be good. Now, I'll give you one example for why this might be the case with oxalate. And I don't know if this really answers the question. This is the only thing that I can think of. Eating a very small amount of oxalate has been shown to increase the production or increase the population of oxalobacter in the gut. Okay. It's theoretically possible. I don't know if I believe it or not, but it's theoretically possible that by going on a zero oxalate diet, you could theoretically be killing off the bacteria in the gut, which allow you to degrade oxalate. Okay. And that by doing so, when you are dumping oxalate into the gut, if you don't have the bacteria present, then you may be absorbing it back, right? That kind of,
yeah.
It's very messy.
But also then you would not deplete yourself because you're dumping actually, right?
What do you mean?
Yeah, if you stop consuming oxalate completely, then your body starts to dump, and then again you have oxalates in your gut, which feed the oxalobacter.
So there you go. The theory that I just came up with falls apart, right? So I have no idea. I honestly, there was one individual, Jack Cruz, who was saying that it's like a reservoir for vitamin C, that you can interconvert the two. I've seen no such evidence. So I've seen no evidence that you can take oxalate and oxidize it back to, or reduce it back to vitamin C. So I'm not convinced that would be the case. However, that is, if there was something to back that up, that would make sense. It would make sense why we produce oxalate, and it may actually be a remnant of how previous kind of, in our evolutionary history or whatever, maybe it was a reservoir for vitamin C. I don't know. But yeah, I can't, the way that I see it, it's a metabolic byproduct of metabolism. We can get rid of it fairly easily, but it can cause problems when you have too much of it. And I would love to know the answer to that question. I'm really sorry I can't answer that.
Yeah, you have answered a lot, man. You can't answer everything, and there's so many things we don't know. And who knows about the vitamin C? The body is just such a miracle thing, and it's able to transform everything into anything, really. I mean, otherwise we would be dead already, with the diets we have, with the lifestyle we have, and we're still we're not thriving, but we're still there, and some of us are doing okay, and this is just because of all these capabilities of the body to mitigate a lot of things,
Yeah.
Is there anything you want to add that you think we have not touched on and that would really be missing?
We've touched on quite a lot, haven't we? We've touched on quite a lot. Nothing that comes immediately to mind. I would say, again, kind of like what we were just speaking about, try not to be dogmatic and take the information that I'm saying, that I've said today. It's based on some research. It's based on some clinical experience. It's based on a lot of anecdotes. I'm not saying that this is the one size fits all. This doesn't apply to everyone. The toxicity does, but essentially, the necessity to go really low oxalate in the diet, I don't think it applies to everyone. So please don't listen to this and get scared and become stressed about what you can and can't eat. It's just about educating you and making you aware so that you're better empowered to make decisions to improve your health. I'm not scaremongering. Like, I don't want that to be the message, that I'm telling people they can't eat this because it's evil. I'm not, I don't want people to get that impression. I just want people to be better informed so that they can try to be as healthy as they can, right?
Yeah, and it's important to know like the top 10 foods or something like that, and then just be aware that just not overdo it.
Yeah.
Like you and me did, right?
Yeah, and if someone does have an established issue, don't immediately drop them, all of a sudden. It's like, right, go onto the resources, look at the Trying Low Oxalates group. So that has like 10 educational modules to like lay out exactly what to expect, what happens, what you can do about it, or seek out a practitioner who knows what they can, like how to proceed with this. Unfortunately, there's not many of us, but just do what you can in that regard. If you're having issues, then seek out some help, join a group, get some advice. It's not advice to do it alone necessarily if it's causing you a lot of problems, because it's very easy to go too low too fast, and it can make you feel really sick. And there's ways that you can mitigate those issues. We've spoken about some basic things today, but again, it is highly individual. So the groups are there. Trying low oxalates, that's excellent. There's a spreadsheet available on there, and there's, as I said, the educational modules, and I think that actually that's a fantastic resource for people, and it's completely free.
Okay, great. Elliot, that was really a pleasure for me. Where can people find you?
Right, so my website is www.eonutrition.co.uk. That's got some little bit of information about myself and the kind of thing that I do. I have a Facebook page, which I don't really update that often, but I post a couple of articles here and there. That's just Facebook EO Nutrition. I am starting to do a lot more on YouTube now, so I've still got a relatively small subscriber base. I think it's about 6,000, but I've got 25 or so videos on there. I like to make educational videos, kind of doing these interviews, but also doing kind of PowerPoint lectures and presentations. I talk about lots of different things there. I've got some videos about oxalates with some of the details and diagrams. I also do a lot of work on some of the B vitamins, primarily vitamin B1. I think that that's a really important one in a modern world. And yeah, people can find a lot of my stuff there. Other than that, yeah, I think that's everything really.
Yeah. Okay. Yeah. And to see you as a medicine practitioner, like locally, where are you based?
Yeah, so I'm based in the UK. Most of my clients, just to be clear, I'm not a medical doctor, so I'm not conventionally practitioner of medicine. I practice functional medicine, which is more nutritional based. But essentially, I actually work with clients from all around the world, right? So what I found is that most of the people that I work with are generally throughout Europe, some of them in South America, some of them North America, Canada. I work via Skype. So if people want a consultation, they can get in contact with me. I have some forms that need to be filled out. And then essentially what we do is we sit like you and me are sat here today. Feels like you're in the same room as them. And we go through kind of the health history and everything. And that's how I work with people. Mm-hmm. So I find it to be very effective. And yeah, it's
health coaching, essentially.
Yeah, kind of that kind of thing. Yeah.
Okay, great. Elliot, that was really a pleasure. And I think we have really done something today. And now I got the work to kind of translate 3 hours of an interview into like, I don't know how I'm going to do this. It's going to take the whole day. Okay. Yeah. Thank you very much for being on the show, and wish you a splendid day.
Yeah, it was a pleasure. Thank you so much for having me on, and keep up the great work that you're doing. I've seen that you've interviewed some giants in the field like Alexander Wunsch, if I'm correct. I think he's fantastic. Stephanie Senna, all of these different big names. Keep on doing what you're doing, because, it's really great and it helps a lot of people. So thanks.
Yeah, thank you. You too. Bye.
Bye.